Welcome, folks, to DConf 2024. I'm excited to be here. My name is Mike, and I'm going to be your guide today talking about the case.
Hey guys, just a quick test to see if, ooh, that's pretty loud, I guess. Just a quick test to see if everybody can hear me. Hearing me okay? Say something in the chat if you can hear me, and if it's not too loud or too low. Awesome, thank you. I'm gonna go back off screen for a second until Átila gets here and we get ready, and then I will be coming back at 14:55, about 7 minutes away. See you then. All right, we are live and ready to go. I've got Átila here in the green room. I can't even speak. I've got Átila in the green room with me, and I'll bring him out in just a couple minutes. I just want to let everybody know what the deal is today. You know, in the past, we had the two separate things going on. We had the live stream going on where I would chat with each speaker and record a Q&A session while their talk was playing on the YouTube channel. Today, none of the talks are uploaded to YouTube. None of them have been uploaded to YouTube yet. You're going to be watching them in the live stream. I'm going to be playing them here from my computer. So hopefully everything will go flawlessly. I have tested and tested and tested, and it all worked for me. So we even did a brief unlisted live stream last week to make sure everything works. So hopefully everything will go as planned. So what's going to happen is I'll bring each speaker in. We'll chat for 5 or 10 minutes before their talk, and then I'll start the talk. And after the talk, we'll do a Q&A session for about 10, 15, 20 minutes, however much time we've got. I want to make sure everybody has time for about a 15 to 20 minute break after each talk. And if you have any questions that you want answered during the Q&A, you can ask them at any point. You know, it doesn't matter if it's during the talk or not. Please tag your question, prefix it with a Q:, and that way I'll be able to easily find them, and we'll make sure that we try to get it answered during the Q&A session. At the end of every session, I will do a random drawing. If your question was answered during the Q&A session, you will be eligible to win a DConf swag item. And, well, I'm sorry, not a DConf swag item, a D-swag item. And what I'll do is I will give you the choice. I'll email you the process if you win. I'll email you and let you know what it is you're supposed to do. So I won't be declaring like before. I won't be saying, okay, this time we're giving away a mug. This time we're giving away a t-shirt. We're not going to be doing that this year. This year you'll get to pick from within a range of items. And then at the end of the day, everybody throughout the day who had a question answered will be eligible for a drawing for a $100 Amazon e-gift card. So that's the plan. Make sure you tag your questions with Q:. Otherwise, I probably won't see them because I've got a filter here I'm going to be searching through the comments for when we're looking for the questions. All right, and with that, oh, I should say one more thing. I'll probably repeat this at the end. DConf 24 in London, September 17th to 20th. Make sure I got the dates right. Yeah, September 17th to 20th. I should be launching the website this week. I've already put out a preliminary call in the forums for submissions. But this week I'm waiting for some final information so that I can go ahead and launch the website. And with that, the early bird registration all at once. That'll be happening hopefully later this week. Shouldn't be any later than Friday. And but for now, you can submit your talks to me, social@dlang.org. If you want to submit a DConf talk, please consider it, especially if you've never submitted before. We love seeing first-time speakers at DConf. All right, and so with that, I'm going to go ahead and bring Átila in. And there he is.
Hello.
Hello. How you doing today, Átila?
Not too bad. Just go off the mountain. Sunny day. Snow all over. Good times.
Yes, it's a great way to warm up for a DConf talk, I guess. Snowboarding.
I guess. I'm not sure anybody's done it that way before, but that's how I roll.
I was going to say, too bad we can't do that in London in September.
Maybe we should do DConf in Switzerland one day.
Yeah, hey, you're going to sponsor us?
Or somewhere cheaper with mountains.
Yeah, there you go. That'll work. All right, so today's talk, why?
Why? Well, first of all, it's because I had to give a talk, so I had to come up with something. And secondly, because, this is something that's been bothering me for a while. I think it's bothered me for nearly forever, really. And, it's one of the aspirational things that I want for D. And somebody mentioned that I should be more vocal about the goals that I want for the language and how I want things to progress. And I should probably talk about it so people know that this is something in my mind. And just because I don't have the time to work on it myself, and I wish I did, doesn't mean I shouldn't put it out there and explain the whys of it and how I would like things to go. And, maybe somebody with more time than me can pick it up.
And so for those of you who haven't seen it yet, the title of his talk is Compiling Code is Boring and I Don't Want to Do It. And this has kind of been a recurring concept for you. It keeps coming up in our meetings. You talk about it. You've talked about it.
Yeah.
You've mentioned it in your other DConf talks. It's come up. So I figured it was just a matter of time before you did a full talk about it.
I guess so. I mean, it's funny I didn't think about doing it before, because I thought in the back of my head that I needed to set aside time and do this properly myself, and then I could talk about it instead of having it aspirational and talk about something I would like to happen. And I did try to I did write some code for this. I just didn't get to the point that I could show anything useful, unfortunately. But I mean, it's a bane of my existence. The only good thing about waiting for the compiler is that I've started walking around the room while it compiles, so it's better for my health, I guess.
I mean, your symmetry code base that you work on, how long do you typically wait for a compile there?
So as most people know, and if they don't, they'll learn now, I don't care about compiling from scratch because that's boring. I don't understand why anybody cares about that. The only thing I care about is incremental compilation, so I've made some changes and I want to see the results, and it's still in the order of seconds, and 10 seconds is just an eternity.
Yeah,
as I tried to explain in this talk.
I'm curious, to those of you watching, what is your pain threshold for compile times? I mean, I'm
wondering too.
Yeah.
And if they say anything that's over 100 milliseconds, they're wrong, and I'm about to explain why.
I'm wrong then. No, I have a very high tolerance for compile times because my projects are small anyway. Whenever I did have projects, I haven't had a project in a long time. But I mean, when I found D, compared to the C stuff I was working on, I just couldn't be unhappy about the compile times.
Sure.
Yeah.
Sure, absolutely. I mean, it can get worse, and again, I go into that in the talk too.
Yeah.
But just because it can be worse doesn't mean we shouldn't aspire to be a lot better than we are right now.
Yeah, absolutely. Well, is there anything else you want to tell people about the talk before we get started with it?
No, I don't think so.
Okay. Well, if there's nothing else to say about the talk, then we'll talk about something else. Tell us about additions.
So I had to work on this, which meant I wasn't working on additions the whole time I was working on this talk, and the trade-offs. But I did get a lot of feedback already from, internally from the D Foundation, the people who at least joined the D Foundation meetings. And my plan for Monday is to go back to that email thread and update the document. And given the feedback I got, and given how little of it there was, but not in a good way, probably after editing it, just doing another round internally and probably showing it to the community.
Okay, yeah, that's about what I figured. What can you say about the current draft, about the details of it right now, as a kind of?
It was simpler than I thought it would be. I mean, when I finished it and I sent that email, I was like, "Is this it? Can this be all there is to it?" I'm sure I'm missing something, but maybe I'm not. I don't know.
Well, what are some of the difficulties that we've talked about?
Templates is one of them, and string mixins. I think templates should be, analyzed from the point of view of the module that they come from, because you always know that from the compiler's point of view. String mixins is going to be a lot harder because, I guess it's technically possible to know, but you call the function that appended two strings, and then this string is supposed to be code that's conforming to what addition, and I think that's probably too hard of a problem to try to fix.
Well, I know we just recently had a planning session about Phobos, and I did not voice this during the meeting, but some of the things we were talking about, I know that we're wanting Phobos v3 to be independent of additions, but I'm not sure in my mind if that's going to be possible.
Yes and no. I think that if the standard library itself doesn't compile the new edition, then we're probably doing something wrong. There should definitely be the test bed, and we should probably, launch the new version of the standard library at the same time as the new edition.
Mhm.
Now, they don't need to be, you know, glued to the hip or anything like that in terms of the only works with this or anything, but it's somewhere between nothing and, completely in lockstep.
Mhm. Yeah, I'm wondering, editions are going to be bundles of features, and to me, I just can't see how we could release Phobos without including it in the bundle, right? I mean, any
Right,
updates?
right.
Yeah.
Right, but I like I said, I think we should move to the new version of the standard library at the same time as the new edition.
Yeah, yeah,
I think that that's the right time to do it.
yeah. So yeah, there's still a lot of kinks we need to iron out on that. What are you looking forward to? We haven't specifically talked about what a first edition will look like, what the feature set will look like. We have discussed future features for, that will be behind editions in some edition, but we haven't specifically planned out the first feature set yet. What are some things you would be looking for first in your mind?
Well, number one for me is safe by default, and my plan is as soon as editions go in, or at least we have a conversation about it, to write a dip about that,
Mhm.
which would be one of the features that goes into the next edition. I think it just needs to be the case, and we need to probably take some ideas from Robert Schadek with regards to making it illegal or at least not safe to slice a static array, because that's obviously a way to land yourself into trouble,
Mhm.
and make things ready so that everything's safe by default and it just works.
Mm.
I think
Yep.
that's number one on my list, but there's a bunch of other things to nitpick as well. I have a list that's going to be larger than most people's. It's going to be larger than Walter's. I can't have everything I want, so I need to go for the things that are more likely to make it in, that have consensus.
Mm. Yeah, my concept of a first edition is just no new features necessarily, but just anything that's breaking, any fixes of the current default language that are breaking, just bundle them up in the first edition and save new features for the second edition. But that's just my thinking. And again, to those watching, we haven't discussed any of this in detail yet.
Yeah.
So,
Well, I think new features that aren't breaking don't necessarily need to wait for an edition. I've read the document that the Rust guys put out about their editions multiple times, and their line of reasoning is if it can be backported, then why not? Yeah, I mean, if it's not a breaking change, why wouldn't we?
yeah. But I mean, I would just like the first edition just to be breaking
Sure.
fixes. Yeah, not necessarily new features, but I don't
Yeah,
know.
like safe by default is one of those things, right? I mean,
Exactly,
this
yeah.
is
Yeah, to get it working like it's supposed to. So, all right. Any final thoughts before I start the talk?
If the compiler is slow, so is the stock, because it takes longer than the compiler, I guess.
Okay, so if you have any questions during the talk, go ahead, and if you don't prefix it with the Q colon, then you're signaling us it's okay to answer during the talk, and you don't want to be eligible for the drawing at the end. But if you prefix it with the Q colon, Átila might
It's a
give
command.
yes, Átila will give he might give a short answer, but if he has a longer one, he'll save it to the Q&A session, until the Q&A session. So I think that's enough chatter. I'll go ahead and get the talk going. See you on the other side.
Hi everyone, and welcome to my talk titled "Compiling Code is Boring and I Don't Want to Do It. Waiting for the compiler is literally killing me." Now, some of you may take umbrage with the fact I'm using the word literally here instead of figuratively, but that's because I literally mean literally. Whatever time I spend waiting for the compiler is time I could have spent playing Final Fantasy VII Rebirth instead. So,
don't make me wait. The one takeaway that I want people to get from this talk is that if it's noticeable, it's too slow. If it doesn't feel instantaneous, it's absolutely too slow. Humans should not be waiting for machines. The machines should be waiting for the humans. Well, when I was a child, I always wondered why there seemed to be wizards in front of orchestras and choirs casting spells with their magic wands. Why are they there? What are they doing? After all, when it's just two people playing or singing, they don't seem to have a problem with singing or playing in sync. So what is it about choirs and orchestras that make that the case? And let's look at some numbers to find out. Well, as it turns out, sound is quite slow, and here's a picture of a sound wave traveling through the air. As you can see, the photographer really managed to capture its essence. Now, the speed of sound in air at room temperature, or so the internet tells me, is 346 meters per second. The actual value doesn't really matter that much. The fact is it's 300 and something, which means that for a sound wave to travel around a meter, it takes about 3 milliseconds for that to happen. Now, if some of you are already thinking, that sounds quite slow to me, that's not really that surprising. We've all seen lightning strikes and how long thunder takes to reach our eardrums. So sound is noticeable in how long it takes to reach eardrums depending on the distances involved. Of course, it seems really instantaneous if somebody's next to you, but that's not the case if they're further away. So it's around 3 milliseconds per meter. Now, why is that important? For most musicians, you can't really notice a delay that goes up to about 10 milliseconds. From then on you can, and from 20 milliseconds it starts out being unplayable, so that if I hear a guitar noise from an amp 20 milliseconds after I've played a string, then I have to adjust my playing to that delay, and I can't play in sync with whatever it is I'm playing. It will be more limited by how long it takes for the sound to get to me. And so this explains why the wizards are casting spells. The solution to this is to synchronize on the speed of light, since in comparison it is instantaneous, especially at the distances we're talking about here. So it's basically not something you can notice, and therefore everybody synchronizes by looking at the conductor. That way everybody's in sync, because physically speaking, those musicians cannot play or sing in sync with each other because they're just too far apart. Okay, but that's musicians. What about normal people? I mean, I'm not a musician. What do I have to do with this? Well, I am a musician, but maybe you're not. So here's an example of video games. Here's a screenshot from Street Fighter 4. It might be the case that other games have this too, but this is just the one that came to mind. This game had what was called one-frame link combos. So the game runs at 60 frames per second. That means that each frame is just under 17 milliseconds. And you would have to input some input sequences that in one case had to be correct to one frame for the combo to link and your opponent to not be able to block the rest of the attacks. And people were able to do this, and even during tournaments with hundreds of people watching, so under pressure. So this is a thing that humans can do. We can actually sync to values around 10 to 20 milliseconds, and we can notice, and this happens. Now, it's also true that reacting isn't the same thing as anticipating. In the case of music, we know what notes are about to follow the one we're playing right now. In the case of combos in a fighting game, we also know what we're about to input because of what's happening right now. So it doesn't mean we're reacting in 17 milliseconds. We can't do that. It turns out that reflex is around 200 milliseconds on average per person. Some people slightly less, some people slightly more, but around 200 milliseconds is how long it takes for us to react to an external stimulus. And then you might say, okay, well, if it's 200 milliseconds, then, the compiler taking another 200 milliseconds isn't that big of a deal. Neither is 220. Well, I would argue that that's not the case, because 20 milliseconds means a 10% overhead over the best possible case scenario in which the compiler is infinitely fast. And 200 milliseconds means 100% overhead on that. So that is quite a bit. And I think that these numbers are important to illustrate exactly how long things take and how noticeable these things are. And 10 seconds to compile is a very long time for a human, and it's infinity nearly for a machine that executes billions of instructions per second, multiple instructions per nanosecond, and the millisecond is a million of those. So it doesn't make any sense for me to wait that long, and it does have an impact. And latency affects productivity, which is why I'm giving you these numbers and talking about how long it takes for human perception with regards to time. I did read a study once, and I think it was by IBM, but I cannot find it again, and I wish I could, because I wish I could produce the numbers that they cited. They measured productivity compared to feedback cycles and how long they took, And the takeaway there was it was a very big difference between, let's say, a second compared to 100 milliseconds. But I don't have the studies, so I can't give you numbers. And the longer it takes to get feedback, the longer it's going to take to progress. Somebody like me that does TDD, the whole loop is you make a small change and then get feedback, please, did the test pass or not? And then you do another small change. And then you might say, well, I don't do test-driven development. Well, I'd argue it's the same thing. You still want to have feedback as fast as possible. Maybe you're doing exploratory programming. You don't exactly know what's going to happen, but what you do want is to make changes to the code and then get feedback, however it may be. It could be visual, it could be whatever it is that you're doing, as fast as possible so that you can go back to editing the code. And productivity, I think, is clear to me that is inversely proportional to feedback intervals. I'm not sure that it's linearly inversely proportional, but like I said, I don't have the numbers. And my thesis is that compile times are killing productivity. And I don't know about you, but the more productive I am, the happier I am. And so I want to be happier. So please stop making me wait. And this is what a typical compiler looks like in the wild. I don't know if you noticed, but this looks eerily similar to a sound wave that we saw before, and that's because they're cousins. But here's the thing though, this is a typical compiler. They take too long. It doesn't make me happy, but things can always be worse, because here's a picture of a C++ compiler having a beer with a Rust compiler. They take even longer. So even though things can always be worse, I don't think that this should be the bar we should set for ourselves. But why are we compiling code anyway? I'm not actually that interested in compiling code, because am I currently releasing the binary? Do I have to actually produce an executable or a shared or static library that I'm going to send to someone or make available on the internet somewhere? Do I actually want object files? Do I want the compiler to generate those and write them to the file system? Do I want to pay the linker tax? Because no matter how parallel we make the builds, I can have 200 object files being generated in 200 threads maybe, but at the end of the day, I'm going to have a bottleneck, which is the linker. And people have tried to make linkers multi-threaded, but so far failed, which means that's still going to bottleneck everything that we're doing. And this is something that I particularly do not want to pay. I don't want to wait for the compiler. I don't want to release a binary. I don't even want file I/O. And why am I rebuilding the world for a one-line diff? If you're building D code, you're probably using dub. And in that case, depending on the size of your project, you might be waiting a long time to recompile, because dub at least doesn't recompile all of your dependencies. But your dub package, if you change one line in one module, you're going to get your whole project being recompiled, every single D file in there. And why are we doing that? Because releasing binaries is something that's done every now and again with release mode. This is something CI could do and create an artifact for you. I joke sometimes saying that this could take an hour for all I care. Obviously an hour is a long time, but it doesn't really matter how long it takes at this point, because this is not something that is part of my workflow. This is not something that's happening all the time. My workflow is I want to get feedback as fast as possible. If at some point in time I'm okay and I have something that's ready to be released, then that could take a bit longer, and it's going to anyway if you want optimizations on. And that's not something that should be part of our workflow. So why are we using it as part of our workflow when it's something that really doesn't really matter that often? Now let me explain this image here, because the prompt for AI to generate it was Átila Neves dreams of a cyborg roadrunner. It can't actually make things that look like the cartoon Roadrunner for copyright reasons. I don't know why he thinks Átila Neves Caucasian, but at least there's a siege happening there, so something's going on. But the whole point is, what is my dream with regard to this? Like, what would be the ideal? I would like for the tests that are impacted to be run. That is literally the only thing I care about when I'm developing. Please rerun the tests. If I've edited only one test, then I would like for that test to be rerun, because tests are special in the fact that they shouldn't at least have dependencies. If you're editing exactly one test, then in all likelihood, the only thing that needs to be rebuilt is that one function that happens to be that test. And if you're editing production code, then it should be possible to only run the impacted tests. So what code depends on this? So we need to rebuild whatever I edited. We need to rebuild whatever depends on it, including whatever tests that actually test that code. That would be amazing if we could just rebuild exactly what's changed and nothing else. Now, what if we have true incremental compilation? I'm not talking about rebuilding one module or one D package when I touch a file. I mean actual incremental compilation of only rebuilding what's strictly necessary. What if the compiler were a server instead of me issuing commands every now and again when I'm done editing? What if it was listening for changes and then we send it the changes and it only reparsed relax, reparse, redid semantic analysis on what was strictly necessary for that change. Because what we do today is do a lot of work, lex, parse, semantic analysis, and then throw it all away, forget it ever happened, and redo the whole thing all over again for a bunch of files that have not been modified in the interim. And that's just a lot of work that doesn't need to be redone every time. What if you got the results nearly instantly because the compiler only redid what it actually needed to do instead of redoing all of this work that it keeps doing over and over and over again? When you're importing a double dependency, for instance, it still has to look at that import. It's not actually going to build that code, but it has to lex parse it and do semantic analysis, maybe instantiating templates, and all of that is done over and over again, even though your code barely changed. What if the compiler was the build system all along? And I'm sorry if this image somehow spoils a film for you, but you're decades too late. Why are we even writing descriptions for compilers to tell them what to build? Why are we telling them what files to build instead of just build the files that are in this directory? Otherwise, why are they here? Why did you put the files in here if you didn't want them built? Why am I calling the compiler over and over again? What I really want is to be able to write a configuration file so to tell the compiler how it's supposed to be called. So things like compiler flags. One thing that's really important is what are the roots to build. So what are the import directories, so the -I flags. Obviously also -J flags for string imports in the case of D, so that we know what the roots are. From then on, I'm importing based on that directory, and I shouldn't have to tell the compiler anything else. Why are we writing build descriptions and trying to make sure that we're not rebuilding the world when the compiler knows what imports what? It already knows what the dependencies are. It has to figure them out for multiple reasons. So the compiler for me should be the build system and should build exactly what it needs to build and nothing else. Sure, there are other things you might need to do that aren't strictly building the code, but that's a different story. When it comes to actually building the code you wrote, the compiler knows more than even you do, and just let it do what it does. But what if I wasn't the only one to think of this idea? I was discussing this with a friend of mine, and he brought up Typist, which is not a project I was familiar with before he mentioned it. And it turns out that this is a tech alternative that tries to marry the best parts of a what you see is what you get system with something in which you write markup that then gets compiled. Obviously, when what you see is what you get, the good thing is you know what it looks like as you're editing, but that has multiple problems that people have run into in the past. And Typist tries to be the best of both worlds. I recommend that you look for the video that shows Typist in action on YouTube. On the left pane, you're editing code, and on the right pane, you have the document laid out and things are happening in basically real time. And so you need to have something be this fast to get that feedback. There's also the Roslyn C# compiler, which they did a lot of work on, especially for IDE usage, and the language server protocol for several languages, because this is geared towards interactive feedback. So when people type in, it has to be fast. And there are ideas out there for incremental compilation. There are ideas of, how can we interpret this the fastest way possible? How can we parse this the fastest way possible? And I'm not going to go into details, the nitty-gritty details of the algorithms and data structures, but there is prior art out there that we can learn from and steal from, as it were, to do this for D. One of the things that I thought was interesting for C# was that the IDE usage was optimized for one file being edited at a time, because people are generally not editing two files at a time. So data structures and algorithms are optimized for that. The other thing I thought was quite interesting was that instead of being given the whole source every single time, what the compiler does, or in this case, the parser, what have you, is the current parse tree and then the textual diff, so that then they rebuild or reparse only strictly what's necessary. The way they did that was with immutable data structures, so you end up having a node point to a new node instead of changing everything. Quite interesting. Like I said, I'm not going to go into details, but this is the idea. The other thing that came up was a pull system with queries and aggressively caching everything, which of course means you run into the problem of cache invalidation. But the idea being, instead of me trying to do everything because there was a diff, how about you tell me what you want and I will tell you what you need to know. So in this case, it would be, well, what are the tests impacted? That would be the query. It would go to the new tree and look at the cache if it has that, and only do that. Again, why are we building the world? I mean, if I change the implementation of a function and don't change its API, the dependencies don't actually need to be rebuilt because nothing changed. It's only that function that needs to be rebuilt. So all of these things are things that we need to look at, I think, and get inspiration from, and realize that this has been thought of before, people have done it, so let's do it. And that's it for the front end portion. So let's parse and do semantic analysis on what's changed. Let's make it the bare minimum amount possible. Let's not redo any work. Let's aggressively cache. Okay, now I have a parse tree or intermediate representation or bytecode, depending on the implementation. But what do we do with that? Because I want the whole process to be fast, not only the first half of it. In my case, I want my tests to run. Well, then they have to run. I need to get the feedback from something. So I thought that maybe the best way to go about this is to try and experiment with just-in-time compilation. What if we could just generate the code as we need to in RAM, cast it to a function pointer, jump to it, and start executing. And this would be amazing because there'd be no object files, so we don't need to actually write the headers or the object files themselves or anything like that. We don't need to be the linker tags. We don't need to be bottlenecked on the linker. We might even avoid template symbol emission problems here, maybe. And we wouldn't even need input-output if the input, of course, came from the editor. So why bother writing it to the disk to then have a compiler read the disk, put into RAM, etc., etc. Let's just keep it in RAM to begin with and go like that. So which JIT though? There are a lot of JIT backends, and of course one could always write their own. And I looked around and there's quite a few. There's libgcc JIT. There's a LLVM JIT, which is pretty famous right now. It's used for SDC's CTFE engine. There's GNU Lightning and Lightning with an E, just to create confusion. The one with an E is used for GNU Guile, which is a scheme dialect. Lisp was really one of the first languages that I know of that you could interpret the code, but once you were done writing the code, maybe you wanted to have it run faster so you can compile it. And most of the implementations compile to bytecode and then have a VM, but in the case of GNU Guile, they use Lightning to JIT compile it into machine code and immediately execute it. There was also Lua JIT bytecode that I was considering trying because it's also famous for being extremely fast, but as it turns out, I read a comment by the author from years ago saying that the bytecode and the implementation are very Lua specific, and he said that a lot of the concepts could be copied for another language, but that it would take years instead of months, but you couldn't really use Lua JIT bytecode as it was for any other language. And there's a JVM, of course, and that also brings up a similar problem because there's several languages on the JVM that found out that trying to translate their concepts to JVM bytecode wasn't that trivial because the JVM was made for Java, the language, and not for any other language. And as it turns out, these things aren't exactly reusable. And which one is the fastest one of these? Now, the thing is, fastest at what exactly? Because you could be the fastest at generating the code itself, like DMD backend is compared to JDC or LDC, or you could generate the fastest code. Well, there's a trade-off there between how fast you generate the code and how fast the code that you generate is. And for me, I think that the only thing that matters again is how fast can you get from something that's already parsed to the result of running a test. So there's going to be a trade-off, a give and take between the code that it generates and how fast it can generate that code. And I don't particularly care if the code that generates is the fastest ever, as long as the whole process, the whole thing is the fastest ever. And so I decided that maybe it would be a good idea to experiment with these different backends. And I thought that binding the DST to different backends would be a lot of work. Obviously, D is not a simple language. DST is a bit large. There's also a learning curve associated to binding to these different JIT backends as it is, and trying to do it with something complicated like the DHT is would probably hinder progress. So I decided to come up with a toy language that does something nearly useful. So a language that's small enough to not be a lot of work to try to actually JIT for, but a language that had just enough features to write a serialization library. Because what do I need to write a serialization library? Basically, different integer types of different sizes. So obviously I need bytes, and I need something else that can serialize that's bigger than a byte. I need arrays of said integers. I need functions, which take whatever parameters they do. I need some sort of equality assertion so I can write tests. So I can say that I expect that if I serialize this thing, then I get this array of bytes. And if I can do that, I think that that's enough an example to gauge how fast these different backends are. And then bind to the different JIT backends, benchmark all of them, and hopefully profit. It is true, however, that D is a much bigger language, and who knows how this would work out in real life with actual D code, but I think that this would be a good place to start. And so I started doing that. Now, I wish I had the code to show here, but I didn't manage to write enough of the toy language to be able to show you any code. I have arrays, but I can't do much with them except pass them to functions and not do much else. I have it doing expressions and generating JIT code and actually doing the thing you want. And I'm only doing this with GNU Lightning for starters. I started with LLVM LLVM JIT, but the API was so bad I gave up. And unfortunately, I have no code right now, but the project is going on. And the ideal conclusion to all of this is that we have fast incremental compilation, actual incremental compilation at the AST node level, the ability to isolate dependencies so that we only rebuild what we need to, and then the fastest way possible from something that's an AST or intermediate representation or bytecode to get into our results. That is the dream. This is the aspirational goal that I mentioned in the description of this talk, and I wish we could get here. The other thing, of course, is that I don't have time to fully dedicate myself to this. I wish I did, but at least I want to put this out there as an idea that maybe the community can rally around. Now, these are some links and references to the things I was talking about. My JIT experiment is the third link there on GitHub. The Roslyn design I saw on Stack Exchange. And Typist, there is a whole paper written about incremental compilation for it in the typesetting context. It was even a thesis, I think, master's or PhD, can't remember right now. So if anybody's interested in checking that out, there you go. And once more for those in the back, if it's noticeable, it's far too slow. And now I guess it's question time. It's going to be weird though, because this is a recording and now we're going to jump to me live. Thanks.
All right. So it is question time. We had a couple of questions during the talk that were prefixed with the Q. Remember, if you want to have a question and be eligible for the drawing at the end of the talk, please prefix your questions with Q:, so we can see them here. Ricky asked, how much do you hate the article from the book Response Times, The 3 Important Limits by Nielsen? And you said you've never heard of it.
Yeah, I need to read it first so I can have an opinion, but I have a tab open on it right now after Ricky mentioned it.
Mm-hmm. And Mike asked, did you see D as a library as a way to support this sort of live coding?
Absolutely. I mean, it has to be D as a library, it has to be DMD as a library because it has to be the whole compiler, because if you try to do anything else, you run into corner cases in which whatever you're doing isn't exactly like the compiler is, and it just has to be that. And as you know, Mike, we have been doing work on making DMD as a compiler easier to use, and given that that work hasn't been done yet, I tried to avoid doing that on purpose for multiple reasons. One is just it's a lot more complicated, and like I said in the talk, there's going to be a learning curve just binding to these JIT backends anyway. So let's just simplify the problem to something I know, and then once I know more about it, actually use the DAST from DMD, etc.
Okay, next question. Oh, I forgot. Hang on just a second. Sorry if you guys can hear my dog. He's whining. He wants me to play with him. There we go. Do you think D's complexity poses a significant barrier to implementing JIT?
Probably, but I don't know yet, because my knowledge of this comes from the comment from the LuaJIT author. Because at one point I said I could just emit LuaJIT bytecode, but it turns out it's not that simple because he himself recommends not doing that, because everything in LuaJIT is designed around Lua, and things shouldn't fit. Like you should copy the design, but not exactly what he did. And as I think I mentioned in the talk as well, there have been problems with languages that target the JVM in the past because the JVM wasn't designed for those language features that aren't Java. And so maybe, but D is complex. However, so is C++, and probably more so. And I know for a fact that people at CERN right now are JITting C++ templates from Python instead of actually compiling them ahead of time. So they're taking C++ templates, parsing them in Python at runtime, JITting them, and then jumping to that code. So if they can do it.
Okay, next question. Hang on just a second. Let me, I'm trying to get, Robert is here in the green room, and I'm trying to get him into the talk. I wasn't set up for 3
Sure.
cameras.
Well, there's a comment there about the CTFE engine. Does some of this already. This is true. SDC's CTFE engine uses a lot of MJIT. I did consider at some point, I think I even mentioned this at DConf, I said something to the extent of, if I could, I would even run my unit tests at compile time in CTFE. And this is what led to this idea of jitting things.
All right.
I mean, at the end of the day, we need a better CTFE engine anyway, right? And bytecode would be a great way to do this. And if we could reuse it, it would be amazing.
Okay, the next question from Ricky. Have you considered a custom loader in a separate process that gets assembly via shared memory? No file writing or JIT required.
Yeah, I thought of that too. But I don't know if that's going to be better or not. I did talk to Amaury, also known as Dadonix, the other day, and he said that given his experience, a lot of the time you want to use the same backend, so it would maybe be better, in his opinion, to use a DMD backend, but instead of writing object files, just write to RAM and jump to that. That's also a possibility.
Everybody, Robert, say hello to everybody. You're on screen now. I don't know if...
Hello, everybody.
Robert's talk is up next. So he came in early, and he had the option of bailing and coming back or letting me bring him in, and I brought him in. So, all right. More questions for Átila? We've got 3 people.
In the meanwhile, I'd like to mention that I spent minutes trying to convince people that 20 milliseconds is an enormous amount of time, and then people in the comments saying, it only takes a second. No.
What's your thought, Robert, on compile times? What's your pain threshold?
Yeah, I mean, to a large degree, what Átila has been saying, I have been annoying Walter about for a long time. I mean, for me, also the LSP thing is an important part of it. Like redoing like everything on the lexing parsing and some of the semantics to just get an autocomplete is just silly. And yeah, like if we can have the best of all those worlds and yeah, control safe and the file has been tested, thumbs up.
Not even it's save. I think that if you haven't touched any keys in 2 seconds, like here, I did this since you apparently are staring out the window.
Fair enough.
All right, more questions for Átila. We've got 3 people on the wheel of names. It's not a drawing, I guess it's a spin. We've got an actual animated wheel this year instead of my silly little...
Oh, nice.
Yeah, I didn't make it. It's wheelofnames.com. They are not sponsoring this live stream.
I was going to ask if you wrote it a D, but apparently not.
No, usually I do, but this year I wanted to do something nicer. So I don't have the graphics chops to make a spinning wheel. Not anymore.
I really wish I had the toy language with the JIT thing, because it's nearly there. Also, by the way, given that I just mentioned that, because everybody's like, well, 20 milliseconds is like, whatever. I know it's a tiny little language, and I know whatever, but it's taking microseconds to parse and then execute the code I'm jitting, which is like, yes. Microseconds.
I wonder if anybody else has thought about this kind of stuff before, or if you're the only one in the community thinking of it in terms of decompilers.
Well, Robert's been, complaining about this for a while too, so.
I haven't heard Robert talk about jitting, though.
Right. Well, again, that idea came about from, I wish I could run my test in CTFE, and then thinking about the new CTF engine, and I went, well, what about we just jit this thing? And I don't know why I'm compiling objects. Because also we've had issues in the past with D with missing symbols because of templates, and this would probably get rid of all that, because you're trying to execute the bare minimum amount of code which also means rebuilding the bare minimum amount of code, and they're not really trying to link anything, so who cares?
RealHet2 says, I usually forget why I started to run compile the program when it starts. I feel the pain too. Delphi in the early 2000s was better, but its optimizer was much more simple.
Right, but here's the thing about optimizations. I don't care. I understand that Guillaume does because his use case is different, and there are people who require release builds because otherwise they can't literally know what's going on. But for the most part, most people don't, and I don't care about optimization at all. That's for when I release a binary to my users, and who cares? See, I can do that.
Remember that D1 project to load object files? Yes, I do. That was it Thomas Stokoyak? Was he involved with that, or was it? It might have been just somebody else. I seem to remember him being involved with it. No, wait a minute. Yeah, I remember the project though. It was really cool. It was the first time I'd ever seen anything like that, loading object files into the process instead of the DLL, just loading directly object files off the disk. So that was pretty cool.
I've tried doing things like myself to try to not pay the linker tax. It didn't work. It wasn't faster. The guy that wrote Gold and now Mold, I think, tried to do. I think is even an option in one of his linkers to do it in threads. It wasn't faster. I think that the way to solve this is to cut the Guardian knot. Just don't link.
Mike asks, have you had any discussion with Martin about LDC2 and the LLVM JIT?
No. I tried the LLVM JIT from the C++ interface. It turns out their own documentation is wrong. ChatGPT can get it right either. I don't know how SDC did it, but once I learned that, I was like, well, at least when I come back to it, I can use those D bindings because apparently at least they work. But it's so complicated, and I'm pretty sure LLVM JIT is not going to be the fastest at giving me code.
Yeah, and at some point probably setting up all the JIT calls will take more time to actually execute whatever you're trying to execute. Like if you can really nail down that that change in that function only affects that one unit test, and you have to sort of do all that shenanigans to set up the LLVM JIT, and if you can just even interpret that one unit test with your change in the function, that's going to be a lot quicker anyway.
Got a couple of comments here from Timon. Having thought about it, my front end tracks dependencies which may be needed to incrementally compile heavily introspective code.
Awesome.
And also, if Timon remembers correctly, Eiffel has a feature where they only partially recompile, and a full recompile was called a freeze or similar. You guys used Eiffel?
No. I've only looked into it because it had contracts, and that's all I know, basically.
Walter says Oplink was multi-threaded and very, very fast. Past tense.
Well, there's fast linkers now. They're still too slow. 1 second is no. Just no.
All right, guys. We've got 3 names on the wheel of names. Anybody else with a question before I call it? All right, Attila, closing thoughts.
I apparently have not convinced people that 20 milliseconds is slow, and therefore what I have to say to y'all is you're wrong.
Okay, let's pick a winner. Who is going to be the one to get some D swag? Here we go.
That wheel is slow, though.
All right, Being, congratulations. You are going to be able to pick out some D-Swag from the D-Swag Emporium. I don't know who you are, so I'm going to need you to please, here we go, I'll get it right eventually. I got all 3 of us now. I'm going to need you to please email me at social@dlang.org, and I will let you know how to claim your swag. Ricky says that you guys are just going to hate what I'm going to propose tomorrow for temporal safety. Okay. Yeah, let's prepare to hate on Ricky tomorrow. Átila, thanks for coming in. I guess you're going to go back to snowboarding now? Or are you
No,
done
I'm gonna
for
watch
the
the
day?
rugby now.
Oh, okay. Not going to watch DConf then. All right. Thanks for letting us know.
Scott, let's play Ireland. What do you want me to do?
All right. Robert, we will be back with Robert's talk in about 16 minutes at the top of the hour. Everybody take a break till then, and we shall see you. Bye-bye, guys. All right, so I've got the comment up here still, just as a reminder, please email me at social@dlang.org to claim your prize at some point after the conference. And Robert is back. This time it's his turn now. And
hello.
Robert, you are talking to us today about containers, the design space of a container library for D.
Yeah.
And I guess my first question to you is going to be, why now? Why this topic? Why now?
Because I felt that there is sort of moving coming up in Phobos and in D around like editions and whatnot, and containers have been on everybody's list for always, pretty much. Like when I joined the D community back in the 2010s, like everybody was asking Andre at the time for a container implementation, and nothing really ever came up. And to a degree, I was curious why, and also wanted to take a look at it and maybe have some input there as well. So now's the time. I cannot hear you.
That's me. Sorry, I muted myself because I had to clear my throat a minute ago and forgot to unmute. So this also came up in one of our meetings recently. We were trying to prioritize some things, and Monkey had asked me, and Monkey, if you're watching this, I did bring your proposal to the meeting when you asked me to, and we did discuss it, and later we discussed priorities. And when we went away individually to set up our own, to rank the priorities from the list that we had of items, I think we were all surprised when containers kind of floated to the top. So this did come up in one of our meetings. So you volunteered to take on the container project as the director, if not the implementer, as the leader, as the organizer, and you wanted to wait until after this talk first. Anything you can say? Any ideas you've got besides what you're going to talk about in the talk?
Not really, but like maybe as a small spoiler, I think there's a very particular reason why we don't have like a de facto container library yet in Dub, for instance. And I think it's like, at least for me in hindsight, it was somewhat obvious.
Yeah, and I kind of agree with you on that. I do think, though, you've given quite a number of DConf talks by now, and there seems to be kind of in the last few talks, there's been like an overriding theme in that basically you've been challenging people to fight you at BeerConf. You've been saying things that are not necessarily mainstream thought, things that are kind of outside where people disagree with you about certain things. How do you feel about this talk? Do you think it's in that category?
Maybe sort of on the front page, but like when we actually meet at DConf later this year, I think people will say, yeah, that was somewhat obvious, but nobody actually said it. That's at least my hope.
Yeah.
Yeah,
I was.
that makes sense. Like,
I kind of noticed in our meeting the other day, you talked about a couple of things that you brought up in this talk, and you got thumbs up, basically all around. And I don't know if everybody saw my eyebrows raise. I didn't expect that. I think that was the first time people had heard you voice those ideas. But you do kind of think outside the box. You're the one who's been pushing for the integrated LTS. LSP server.
LSP language.
Compilation in the background and all this stuff. What motivates all of that?
So like for work, I'm using two languages mostly, which is D for the back end and TypeScript for the front end, like both from NeoVim. And the LSP server in TypeScript is just awesome and helps me quite a lot. Like we're using Angular as the framework to build the web front end, and the autocompletion for methods that I sort of would assume exist but have no idea about the name, and like the whole workflow is really, really quick. And the work that Jan has been doing for the debug end is awesome, but obviously like there aren't just those resources that Microsoft can throw at such a problem. So obviously it's not up to spec to sort of to say that. And like I've seen other people use LSP, and it's just sort of came out naturally, like as a want for me personally.
Well, yeah, we all
other people.
We all use it, but I mean, what made you think it of running the compiler as a daemon and making the LSP built in? Where?
I don't know. Like at some point, it just like as I said, at some point I just realized that the compiler is doing the same work over and over and over again. And I would say, as most programmers try to be as lazy as possible, that doesn't sound lazy. Like, why repeat yourself if the result is already existed in your memory at some point? Like, why would you do it? And then if you sort of connect it and think about it a little, that sort of comes out at the end, I would say.
Well, I remember back in the day when I first saw, when I was still using Java, and I first saw Eclipse, compiling in the background, and the compilers running. That was the first time I'd ever seen anything like that. This was early days of Eclipse, I think, and it kind of blew my mind. But it never occurred to me that we could do the same thing with natively compiled languages.
Yeah. I mean, if you're really pedantic, you might even have an LSP server for assembly. I mean, it's a true and complete language. You can do everything that any other language can do. Probably not as useful to have it in assembly, or maybe even more, depending on how you look at it. But yeah, I mean, good ideas are there to steal. And if other languages have good ideas and they make sense in your context.
Well, how would you rate? I mean, these are both big projects. The container library has a lot of corner cases to consider, and a lot of unresolved questions about immutable and const and all this other stuff. And then in terms of like the compiler daemon, LSP server, and the background compilation, that has issues with the architecture of DMD. Which do you think is the more complex project that's going to be challenging?
The more complex one is, I would bet, is the compiler daemon, because you basically have to track like the whole dependency tree between everything. And that is quite a lot. And also, like, then you sort of have to rebuild parts of the tree when you do compile time function execution, creating a string that you then mix in. That I would say is definitely the more complex task. And then also, like, when you design a container library, like maybe spoiling the talk here a bit, is that I would say you have to really focus on performance as the overriding goal. And that, I would say, makes many decisions easier, because, well, you're going to try to make it as fast as possible and not really care about const and immutable as much if it's sort of in the way of performance. So, yeah.
Yeah, well, both of these are on our radar as priorities. Any final words before we start the talk?
No. I just dread seeing myself and hearing myself talk. That's, as Átila said, it's always strange and weird, and but it's a good exercise to see yourself every once in a while.
All right, well, close your eyes and plug your ears, because here we go.
Hi, I'm Robert, and if you made it here, you already read the title. So let's get started. When you come to D, One thing that you will most definitely miss after a little while is standard containers like C++ has std vector, std map, std set, and all the other. I have been one of them. I have been asking for an std vector, an std set, and all that in D. And obviously I also want a good one, but then the question becomes, what is actually good? This is what I'm trying to gonna answer in this talk, and we're gonna see where this leads us. Before we actually start about what is good, maybe let's explore the design space a bit. Obviously, safe is a factor in it. We don't want our memory to be corrupted all over when we use the container. We have to think about constness. So how does the container handle const values? What happens if we have a const container? Also, allocators play a role. Like when we allocate memory, we actually have to think about that a little bit. If we want to really dive into, maybe we want to provide our own strategies how the container allocates memory. But that also has consequences. So for instance, what happens if the allocator goes out of scope before the container goes out of scope? Then also, what happens if we nest containers? So let's say we want to create a multidimensional vector, and that internal vector also should use the same allocator as the surrounding allocator. Or what happens if we have const nested containers? The next thing that has to be discussed is obviously iteration. So D uses ranges, so obviously the containers should be able to work with ranges. Also, always an interesting topic of discussion is how we handle exceptions. And one obvious exception that will happen is bounds check. So let's say our vector has 10 elements in it, and we want to access element 11. What should happen? Should we get an exception? Should we corrupt the memory, or should we read from uninitialized memory? What gives? Something has to happen there. Also, what are containers, sort of technically speaking? If I return a container from a function, do I get a copy? Is it internally holding a reference to something or a pointer to something? Do we do copy on write, copy on modify? I don't know yet. What about performance in general? Do we do small size optimization? How do we integrate the bounce checks into the iteration? So how do we get performance out of it? If we have an std vector in D that isn't as performance as the std vector in C++, people will obviously complain. Maybe rightfully so. Maybe there's something that the C++ implementation doesn't do that the D implementation does. Well, that's not also important, but also actually yields the benefits. And then what types of containers do we actually want? Do we only need like a set and a map? Or do we also want to have a vector, an unordered map, an unordered set, a linked list? Who knows? And then sort of the last question I sort of thought about when iterating the design space, what about multi-threading? How does the container library work with shared? Is it log-free? Do we have log-free implementations of containers? How do we do multi-threading? For instance, we could say that consideration that has to be taken here is how do all those design criteria interact with each other? If we have a const container or even an immutable container, multi-threading becomes easier. But if it's an immutable container, how do we get the elements in it? Does it even make sense to have an quote-unquote immutable container then? Because as far as I have used containers, their contents changes. So all those questions have to be evaluated in the context of all the other design decisions that can be taken. So maybe let's begin and see where this road leads us. Let's start with a somewhat simple one, bounce checks and exceptions. If you say exceptions in the D community, people will say we can't have exceptions, they're slow, they're bad. Maybe there's something to it, but maybe there's something in there that actually has a valid reason for them to exist. So here we have our quote-unquote vector that is templatized on a type T, and internally we implement that via an array, so it's easy sort of to test ideas out. The most prototypical implementation of op index, so the square brackets, is that you return a reference to that element indexed by the parameter IDX. And if that index is greater than the length or greater equal to the length of the array, we have to say, we have to throw an exception with an object out of bound or index out of bound. If that is not the case, so we are within the bounds, we, for performance reason here, basically or to not replicate the bounce check, we take the pointer of the array and add the index to it. So we offset it and then dereference and return the reference. That works, but we have an exception in there. And people will say we can't have exceptions. But then even this code has to be marked trusted because you are accessing the pointer to get the performance. And if you remember, in safe code, you can't take the pointer of an array and still claim it's to be safe. If we don't do that, we get the normal bounce checking of the array internally. If we get the memory from somewhere else, we likely have to do a cast at some point, and that also can't be safe. So something has to give here. Like we can't pretend that safe without bounce check or that access without bounce check is safe, but at some point I would argue we start lying to ourselves. And I would like to avoid that for at least as long as possible. Another option to do this without the exception, but also not really safe, is to not return the reference to the object directly, but return a pointer to the object if it exists in a nullable. That has the nice advantage of it forces the user, when they get the object, to actually check or use get to get the value out. So if the index is out of bounds of the array, return the initial state of the nullable, which contains the value. And if we ask, is this thing null? It will tell us yes. In the other case, we take the address of the index. Again, here we have the bounce check. Otherwise, the compiler couldn't infer safe on that function. And we return a nullable of the same type, but now with a pointer to the value. Also good, but that basically requires that we have to have yet another check in the user code where we check for the nullable to be null or not null. And the sort of third implementation I would offer as an idea is we have changed the signature of a function a bit. We return the nullable out as an out parameter, and we directly return a bool telling us whether or not we actually are inside of the bounds. And the implementation is quite simple. If we are within the bounds, we return the nullable with a pointer via the out parameter and return true. If that's not the case, we're going to return false. But what I was trying to illustrate here is that no matter how we twist or turn it, at some place in our code, we have to check if our index of our vector is within its bounds. And like how we do it is, I would say, of second rank order. There's always going to be a branch in there. And the branch predictor in the CPU is always going to have a hard time figuring this out. It can speculate, but sometimes it just is wrong and then the pipeline gets stalled and the performance decreases. So this also plays into the performance design space of the whole library. I would say at this point, exceptions are easy because most deprogrammers are used to an out of bounds error at this point. And I think having a new container library in the language that doesn't trump people's exceptions too much is a good thing. So I would say the third implementation might be interesting to use in new user code. But if you're replacing an array with a vector, you would really be surprised to find that kind of interface. And I'm pretty sure people would argue against it. Maybe even I would argue against that. But that is something else that can be discussed later a bit more. For the continued discussion in this presentation, we're going to assume that STD allocator or STD experimental allocators made it out of experimental, and we have the ability to define very elaborate user-defined allocators. And this is one that works. And here we're going to say the thing allocator is basically this thing. So whenever you see an allocator in later code snippets, this is the allocator I was talking about. But it actually doesn't really matter like how we use the allocators. The interface is always the same pretty much. So let's continue. One of the core problems I see with allocators and containers is this. So let's assume we have our vector1 implementation that takes two parameters, the type of elements we want to allocate, and an allocator itself. For demonstration purposes, this one is cut very short. We actually don't do any vector implementation. We just store the allocator and then assume that if we want to append to the vector, this allocator gets used to get the memory or extend the internal array or whatever data structure you use to store the vector. And the unit test basically shows the problem. So on line 6, we define a vector called vec that takes int and an allocator. And in the block statement starting on line 8, we define our allocator and we create a vector that we assign to the vector defined on line 6. At the end of this block, to not have memory leakage and not rely on the garbage collection, because if you talk to many people in the D community, garbage collection equals bad. The allocator, so toAllocator, has to deallocate the memory, meaning that after the block statement, the memory that is potentially used by the vector doesn't exist anymore, meaning it is not safe, meaning that at least when we develop an allocation and if we develop a container library that allows allocators to be used in this case, it's going to be very difficult to return containers from functions and making it safe. So for that to work, you basically have to pass in the allocator as a parameter to the function that outlives the return value of that function. One possibility to do this, and D allows this, is to disable the post-split constructor and op-assign. And in this example, we basically the same thing. Only difference is we call it vector2 to make the distinction. We can create a vector on line 13 that exists, but we cannot create a vector as shown on line 16 and assign it to the outside because we disallowed op-assign, meaning that this vector can only be constructed in place and exist there, and it can never be reassigned. That is a possibility and would circumvent the problem with the allocator going out of scope before the memory used by the vector goes out of scope, but I'm not sure if that is actually something that we want here. Let's also shelve this problem for a little while and continue on something else, but not really something else, as I would argue this is mostly the same thing. So again, let's assume we have a vector. Internally, we use an array to represent the data in it. Like how we actually do it here doesn't really matter. It applies to all possible ways of doing this. And we have a couple of functions to get the elements, like a faster one and like one that also does the bounce check. And we have two slice function, slice pointer and slice index. And they both return different types that allow to iterate the vector. And we're going to start with via index. And here what we do is we have members in that structure. One is a pointer to the vector itself, and the other is the current index and the end we want to iterate to. And then front is relatively simple. We take the pointer to the vector, use op index fast, pass in the current index, and return the reference to that value. Pop front is as you would expect. You just do ++ on the index, and empty is also a very simple check where the index has to be greater or equal of the end to have found the end. The problem, as can be understood from the unit test, is the via index is also something that can be returned from a function, and it will have a pointer to the vector, and if the vector is out of scope, we basically have a dangling reference. If we dereference that, in the best case, we get a seg fault. In the worst case, we overwrite memory that, well, shouldn't be overwritten anymore. And if we do the same via pointers, so basically have a pointer to the current one and to the end, the code changes a tiny bit and might just be a tiny bit faster, but the problem still persists. We have at least one pointer to a vector that can be out of scope. My argument here would be that having allocators and ranges as iteration mechanisms basically creates the same memory safety problem. Sort of the basis of the whole argument I want to present here is that safety should trump performance. Unless you really want to hold up a sign and say, I have a foot gun and I'm doing dangerous stuff here. Meaning that if we allow interfaces that are potentially unsafe, we should never mark them as safe. You have to say, I'm being a bad boy here, I have the sign, I'm having a foot gun, and I'm doing something that is potentially faster, but also most definitely not safe. The next thing I want to talk about is constness, and implicitly also about immutability. On face value, everybody will tell you const is a good thing, and I would agree. But also const, I would say, is a bad thing in that it makes most interfaces not nice to look at. And I would also argue that many people, or most people in the DE community and outside, would say that D looks nice. But if you, for instance, look at the op index implementation on line 13, we have this weird in-out thing to basically allow the vector to be not const, but also const and immutable. So basically the type of t or the qualifier of t is dependent on the state of the vector or the constness of the vector. And this gets really ugly quickly, and also I would say ugly to a degree where people don't want to use it. Like it's just a hassle at some point if you have const all over your code to make that work. And yes, the compiler can infer some stuff, at least for templates, but then if it doesn't, it's really difficult to figure out why that is. And I'm not sure if there is a systematic way to make that easier to use. And if you have read the recent survey that the Rust people did, the biggest pain point people had were basically that the language has become too complicated. And I would say const and immutability on containers is basically taking the road towards making language even more complicated. And I'm not sure if that is a good thing. At some point, you can argue, yes, that's the right thing to do because it's correct. But then I fear that there's nobody that will actually use it because it's too complicated. So what have we won then actually? And this basically leads me to like a break in my presentation. All of this so far feels wrong, and we haven't really touched on most of the attributes or items in the design space that are laid out in the beginning. I would say program language design, and by extension, standard library design and container design, well, we are not discovering physics. It's an engineering discipline. At some point, we have to make trade-offs and take decisions. I think building a container library in this way is making the wrong decisions. So maybe let's explore this a bit, and maybe we can find something else where the decision taken reflects more of the values of the language and not the attempt to be physically correct or having like a mathematically proven design space exploration. So before we go there, I will try to figure out what it is we can actually gain. One thing that we can gain that we don't have right now is allocators. I absolutely agree that there's sometimes a need to have a user control on how memory gets allocated and not having the garbage collection one. I absolutely agree. But also another, I would say, even more interesting thing that we can gain is deterministic destruction. I bet we all ran into the problem where we had a dynamic array of files, and then sometime later we're surprised that the files haven't actually been written because their destructor hadn't been called. Like I have been guilty of that, and I bet other people have as well. When I learned C++, the biggest gain that it had over Java, which was the first language I learned, was the deterministic destruction of objects, and also objects stored in std vector. Like having std vector call the destructor on something just worked, and it's a really important and good feature. Like fundamentally, I would say those two things is something that we should take a look into. Then also, what containers do we actually want? Maybe like looking at it from those two angles, we can figure out what we actually want to gain here. We definitely want to have like a vector or global array, and we also want to have a hash map and a hash set. I know linked list exists, and I know that like maps and sets that are based on maybe a red-black tree exist as well. But there I would say performance will tell you to not do that, because basically all those things is invalidating your L1 cache on every read, because it's basically chasing pointers wildly through memory. Unless you have a linked list implementation that is pretty much underlying just a vector implementation where the pointers always point to the sort of memory that is adjacent to each other, you're going to have a very hard time making it performant. So I would say let's sort of put those three things to the side and maybe focus on the other two a bit, or other three a bit. What do we have to pay for all of this? I would say if we have allocators, we cannot have safe code. And everybody that says they're going to have allocators safe, I would say maybe you are pedantically, theoretically speaking correct, but practically you're lying to yourself. I just want to phrase this as hard as possible, because I think those two things should not go together. If you do allocators, you have to hold up the sign, I'm being a bad boy, foot gun, watch out, and let's leave it at that. Deterministic destruction, I think this is something very interesting and important. So sort of to nail the point home about allocators not being safe, this is the interface for Rust, the safe programming language, for their allocators or for their custom allocators, and actually also for their default global allocators. And they don't have the safe keyword, they have the unsafe keyword. And as you can see, it's all over the place. So even they can't do it, and I would argue that we shouldn't even attempt to do this. I'm pretty sure that the amount of useful things we're going to get out of it at the end is just the empty set. And what's the point then? So perfect is the enemy of the good. Let's have a look. D already has magic for arrays in the language built into the compiler. We have a function called fun, and it takes an array of constant integers. And this unit test compiles, even though on line 7 we create a const int array, and we can pass that to fun. And the compiler says, yeah, that's fine, take it and move on. Also in safe code, this just works. Maybe instead of thinking of magic as a bad thing, maybe it's actually a good thing. Maybe having the compiler being smart about some specific types is really a good thing. I mean, we also have polymorphism for classes, which I would say is also magic. Like, I never had to create a virtual function table by hand to use that, and it's just there and it works, and it's magic, at least to the layman user that hasn't implemented the compiler. So maybe we can lean into this a bit. Let's assume we have this function here. We have a median function that takes an array and computes the median of the values in that array. The implementation of median is very simple. If it's of uneven length, we just return the middle element, and if it's not, we return the average of the two elements around the middle. I bet all of you have written a function like this. You read some text, you split it on the white space, you map the individual items to their length, you take an array from it, because the sort function requires an array, then you unique it to only get unique entries, as said, and then call another array function call to turn it back into array, because unique is a lazy range. And then you can pass that to the median function and you have your result. Works fine. But actually under the hood, there's quite a bit of things going on about where arrays are allocated, and my suggestion would be to add a bit of magic into the compiler to get some deterministic destruction. When the unit test gets out of scope, the compiler, I would argue, can know that the array by length no longer can be accessed. And what that means is that the compiler can free the memory. So basically insert a GC free, or if it were not just unsigned longs in the array, also call the destructor on it. I mean, this code works perfectly, and maybe the compiler not necessarily has to do the release via the garbage collection, which might trigger a collection phase, but I think those are things that can be tweaked by the people implementing the magic and make useful trade-offs there. But actually, the compiler could do a lot more. Technically, I would say there are at least 3 deallocations that can happen here. Let's divide this up a bit. We first read the text into a new string called text, because that's what read text does. And then we again split the text, take the length of the elements, take the array of that, sort that, and then call array a second time, which actually is pretty much just a cast to get the sorted range back into an normal unsigned long array. And after this, on line 10, the text is no longer needed. There's no residual reference to any of the data allocated byte. So the compiler could insert a GC free statement there. And on the next line, we unique the array and call array again. At that point, the compiler could also know that no longer is the A array needed anymore. Then we call median with the value, print that out, and after that, we can also release the by length array. I would say with all the analysis going into DIP 1000 and its successors, implementing this in the compiler for most things shouldn't be so difficult. Also, an interesting benefit of all that is that our median function actually is pure, meaning that pure will extend its usefulness quite a bit. Not only does it make debugging easier, but also it actually helps the compiler to make better decisions about what memory can be deallocated at what place in time than having to rely on the GC to actually figure out that there's no residual reference. So the array here cannot escape the median function because the function is marked pure and we can't assign it outside of the median function. So I would say when we actually acknowledge that arrays are already special and or magical in D and are okay with that, we could actually make arrays a lot more useful. Also, a bit more magic. Currently, having a set in D with associative arrays is possible with a hack. So there's basically a trick to get the void here that isn't writing void there, because that wouldn't actually compile. Why can't we have a bit more additional magic to make this possible? Like, I can't really see why, other than having the argument that it's not nice or that it has to be implemented by a library. Why? Like, we are the compiler devs, we are the library devs. Why can't we have this? Just because it's not nice or theoretically pure or whatever? I don't care. I'm an engineer. I want my wrench that works on the bolt. I don't care if it's the right metal, as long as my bolt is fixed in place and holds. Cool. The wrench breaks every once in a while. Well, then hopefully I have some debugging tool which will tell me that the wrench broke. But it's fine. It's better to have something theoretically that is absolutely unusable that tells me this bolt can be tightened with something, but then actually using it is gigantic pain. Why? I don't want to do that. If I hadn't ranted enough, there's a bit more ranting going on now. I think at some point we can't have the cake I needed to. Safe and allocators, like if anybody brings that up again, I'm going to tell you, no, not a good idea. The reasons I just listed out. Also, one thing that I think we have to consider very heavily is the barrier to entry. Like, if you have to understand basically all of the templating syntax to get deterministically destroyed dynamic array in D, I think we have failed. Everybody's going to choose Python because lists just work, and they don't even try to offer that feature, but everybody acknowledge that it doesn't exist there. I think it has to be easy understandable. And when I came to D first, dynamic arrays were wonderful, easily to understand, and I really liked that. And slices on that, just perfect. Like, best thing about D, absolutely. And it also has to look and feel good. I think that sort of goes back to the point about the barrier to entry a bit. The error messages you get from very deeply nested templates is just a very bad look and feel. It's also cumbersome to learn and understand, and I think it's just the wrong trade-off to do. One more rant. What I've seen over my, 10, 12 years in the D community, and especially with code.dlang.org, for most problems, there basically has been a de facto library that does that thing. And sometimes those libraries make it into FOBOS, and sometimes they're just used and everybody knows that they're basically an extension to the standard library. That has not happened to containers. There are a couple of implementations of container libraries. Some support allocators, some don't. I would argue that is the point, because the inbuilt dynamic arrays and the inbuilt associative arrays are so good that the benefit that any library yields on top is not worth the hassle of actually using it and the diction and the pain of dealing with the interface. So that is absolutely not scientific, but I would say engineering isn't always scientific. Sometimes it's also a gut feeling, good taste. And I think that is sort of it. It's difficult to put that into words or even better, a theorem. It's just that having seen enough code that a dynamic array most of the time is better than reaching for any of those container libraries. I think it's going to be extremely difficult to develop something better here. So, conclusion. I would say almost always reach for normal dynamic arrays and also associative arrays. And then for a very long time, there's nothing. Like, you really have to justify your choice of doing something else than those two. I would argue if the compiler were able to insert a bit more magic there and make, for the most part, deterministic deconstruction of dynamic arrays and associative arrays a possibility, for 99.99% of our users, they wouldn't need anything else. But for the few people that actually need it every once in a while, and I acknowledge those exist, there need to be unsafe containers that require an allocator. The allocator at that point must no longer be an option, it must be a requirement. This is basically holding up the sign, I have a foot gun here. The implementation of those can be as unsafe as possible, but one thing they must never be, and that is be at safe. So that brings me to the end. And if you have any more questions, keep asking. Thank you.
Okay, and that was
Okay.
good talk, Robert. Now let's see what everybody has to say about it. Who's going to disagree with you? Who's going to fight you? We have some questions. Remember, if you have a question for the Q&A session, please prefix it with Q: to make sure that I know it's for Robert and it's not part of the conversation, and that I even notice it, because right now I don't see the full comment stream. I've just got to filter up for the Q:. And we have
Yeah,
three.
the comments have picked up a bit at the end there.
Okay, so we have some questions out of the gate here. Speaking of Andre, what is he up to? Right, so that came in, I think, during the pre-talk chat we had. Yeah, Andre is working for NVIDIA as a researcher, and he's still involved with the D Foundation. He still is the prime manager of our finances, and he's also attending our meetings when he has the time for it. So he's still around. He's just not involved in the day-to-day operations anymore like he used to be, but he does give his input. He's kind of like a consultant for us now, I guess, would be a good way to call it. So, yeah. All right. And the next question from Ricky. Without a borrow mechanism tied to DIP 1000 that XORs mutation with borrows, sorry guys, I got to remember to do this. This is a new thing. I haven't had this for past DConf Online or DConf Onlines. Yes, with borrows, you will always have logic errors that result in memory safety fails. Thoughts?
Sort of connecting to my last DConf talk, I think DIP 1000 and the scope and scope ref syntax should be something for trusted, not for like the bread and butter code that we always write. To be honest, I like safety better before DIP 1000, even though it was more restricting. And as in my last DConf talk, I would say sort of the non-trusted safety, or the safety, or the safe 2 by default should be even more restrictive, like not being able to return by ref, and not taking the address of anything. So yes, your argument, Ricky, there might make sense. I don't know actually, but I would say it is the wrong design decision in general.
Okay, and from Snarwin, in non-toy examples, how could the programmer be confident that a particular data structure is destroyed when they want it to be?
I think that question is quite open-ended. I mean, how does the garbage collection know, right? Like somebody has to figure this out, and if in safe code you can compute this. As a human, you can compute this, and most of the rules that you have to follow for that are not that complicated. But obviously, when you get cars involved and suddenly your void pointer is a pointer to some elaborate class structure, things get more complicated. And that basically is one of the reasons why certain things in safe code are not allowed. And I would say it is just an engineering effort at the end to make this work.
Okay, and question from Serg. Many containers are part of Otherling's standard or library. Do you think having only dynamic arrays and AAs is a good strategy for language promotion in the competition? Which message D advocates should use?
Yeah, that is like one of the meta problems I see for D. Like, for better or for worse, the different industries that use D are very different. Like, we have server applications, we have high performance file systems, we have some people trying to use games, even though it has slowed down a bit. Then we have like the microcontroller no D runtime crowd. And like, from what I've seen in the last, let's say, 5 to 7 years, programming, like the engineering discipline of it, isn't really that ingrained in people anymore. It's what you actually get out of it. So I would bet that most people that use Python to do AI don't actually know how that stuff is executed on the graphics card. They probably have no idea about, well, hopefully those people won't now gang up on me, but I bet many people probably don't know how like the GPU executes it ultimately. And I would say they don't need to know. Like why? They want their LLM to do something awesome, and that's fine. So, and for them, I would say it doesn't matter how we get there. Like, and they don't care if we have like the fastest dynamic array. And from what I've heard, even for the C++ crowd that is doing video games, most of the STLs they use are custom implementation for their specific hardware. And they probably have a different implementation of the same vector interface for different hardware. So in my opinion, the standard library should do most cases well enough that you get most things done. And every once in a while, you have to roll your own to get the last bit of performance out of that specific nested for loop where all your performance goes after you have done the profiling, of course. So like just having all, I would think is ultimately not the right thing, because people also get overloaded with information, as we all do probably on a daily basis. I hope that answers the question.
All right. And we are cutting into our break time here, so I'll cut off the questions there, and it's time to pick a winner for the D swag. But before we do that, any final thoughts to leave everyone with, Robert?
No, not really. I should have thought about this before, because you asked the same thing to Átila. Yeah, I mean, keep the critique coming and do awesome things with D. I think that's the best thing we can do for the language. We might most definitely will not agree on everything, but like trying to see the positive angle people are coming from towards the language, and most people here are actually coming to D because they like it. I think that is important. And if we disagree and you think what I do is not great, but you think I do this because I think D should succeed, then that's all we can ask for.
All right, thank you. And a comment here from Walter. Your thoughts on simplifying D are very insightful. And I think that is true. I agree. All right, and we have 4 names for the wheel, and let's see how it goes. One of you will win your pick of D swag, and it is BS Doobie. Okay, so please email me at social@dlang.org or message me on Discord, whichever one it is, and I will let you know what you need to do to claim your prize. And so that's going to be it for this session. And when we come back after the break at the top of the hour, hopefully we will see Timon here. I hope he's here. I know he's around in the chat. So. Yep. All right. So everybody take your break, and we shall see you soon. Robert, thanks a lot for your talk, and thanks for the chat.
Sure, always.
I always enjoy talking to you, and we'll see you at the next meeting, I guess. Yep. Bye-bye.
Yeah. Bye.
And here we are. I'm here with Timon Gehr, Timon Gehr, and he's going to talk to us today about tuples. This ties back into your DConf 23 presentation, which was your first DConf presentation, amazingly. And you submitted 2 talks for the conference last year, and one of them was about tuples, and the other one was about, what was the other one
types.
About? Types, there we go, yeah.
Types, yeah.
And
types in D, basically.
Yeah, and we asked you to combine them because we wanted to hear about both of them. And you didn't get to cover tuples to the degree you wanted to. So this is your opportunity to do that today. What is there anything you want people to know before the talk starts about what they're about to listen to?
Well, I mean, basically, D does not have tuples.
Mm-hmm.
And I think it would be good if we had at least some sort of unpacking. Mm-hmm. But I mean, the talk will cover that. I mean, I've been working on and off on an implementation, but
yeah, and I think
it's a bit hard because people don't really agree what the tuple should be in D.
Yeah. So that's the big sticking point. I think it's not whether we're going to have tuples. It's how we're going to have them. I think, right? Walter is on board with adding them to the language, I believe. Have you heard? You haven't heard anything to the contrary, have you?
I mean, I think Walter in general is on board with having tuples. Mm-hmm. I'm not sure if he thinks that's the same thing that I think it is.
I see. So in principle, we're going to have tuples. It's just a matter of what they're going to look like. You've been maintaining an implementation. Okay, here we go. Yes, I'm on board with tuples, says Walter.
Same.
Yes. So you've been maintaining your own implementation or your own fork of the compiler with the tuple implementation in it. Is your fork up to date, or is it?
I mean, unless there have been pushes to master in the past couple hours, it's up to date.
Right. Okay. So you've been keeping it up to date. Has your implementation of tuples evolved since you first implemented it?
Yeah, I mean, first I went with the design that used alias this that I also described in the deep draft, mm-hmm. But Walter was kind of not on board with this alias this design. So I've been trying something else, but it's not done yet.
Okay, yeah, because that was going to be my next question. If you had a dip that was approved today, what would be the lead time? How much time could we see between getting your implementation from your fork into the main upstream?
Well, I mean, I guess that depends on the scope of the dip. I mean, if the dip just has tuples in it, then maybe a couple of weeks, I guess.
Yeah. Okay, so we'll keep our fingers crossed that it gets to that point. Besides tuples, which we're about to hear about, what are some other features you're hoping to see, or that we're going to get, that you're looking forward to?
Well, that's a hard question, but I mean, I guess the big thing would be move semantics.
Okay, Bastian, let me know that my mic is picking up the sound of my shirt. Sorry about that, guys. I'll go ahead and keep it out to prevent that from going forward. Yeah, so I mean, some types.
Yes, I mean that's another thing.
Mm-hmm.
That would be good to have, but there also, I guess, question is what we're going to get. In my opinion, it would be good to have some types that check at compile time whether you handled all the cases and don't crash at runtime.
Mm-hmm. Have you've seen Walter's original proposal for that?
Yes, and my main critique of that was specifically that it has runtime crashes and no exhaustiveness checks. But also he didn't include pattern matching in that, so it's kind of not clear what it would look like.
Right. And I think, was it Ricky who had a proposal also? Have you seen his?
Yes. I've also commented on that. And I think it is a bit of a mix of structural and nominal typing. And I'm not fully on board with that, but in general, of course, you could have structural sum types, just like you can have structural product types, which would be tuples. Right?
So we're going to have, I guess, a lot of debates about which, I just got a message. We're going to have a lot of debates about which sum type implementation. There's no other competing tuple implementation, is there? Or proposal, I'm sorry. There is no other competing proposal that I know of, is there?
I mean, there was the original pull request in 2011 by Kenji Hara.
Uh-huh.
That is slightly different.
Yeah,
it's just for unpacking.
Yeah, okay.
But
nobody else has it.
There's also tip 32, also by Kenji Hara, which suggests to use a completely different syntax.
I see. So I guess that's on the wiki?
Or yes, it's on the wiki.
Yeah, I see. Yeah. Okay. All right. Yeah. Well, I know you're going to probably submit a talk to DConf in London, yes?
I mean, I hope so, if I can find something to talk about.
So you don't have anything in mind yet?
Not yet, no.
I was hoping to get a teaser out of you for people, so I guess we're not going to get it. All right. Any final thoughts before we start the talk? Anything you want people to know going into it?
Well, have fun.
All right. That works for me. I'll go ahead and get it started. Here we go, folks.
My name is Timon Gehr, and I'm going to talk about tuples in D. This is an aspirational talk. What you can see here is not yet valid code. In 2018, Sebastian Wilsbach has initiated a survey about the current state of D. One of the questions was, what language features do you miss? About half of all people responded, and about half of those missed tuples, which makes it the most missed feature in D. 2 out of 3 of the top features have implementations about the land in the reference compiler. However, this is not yet the case for tuples, which is the top most requested feature. Tuples are useful because they allow ad hoc packing and unpacking of related data. This is good synergy with ranges and generic algorithms. Keep in mind that only about 25% of the respondents actively miss tuples. In 2012, Verifier gave Huffman coding as an example demonstrating the utility of tuples. Each character is mapped to a binary sequence. This is an implementation using exclusively existing language features. You can see related values being packed and unpacked using explicit indices, which makes the code a bit annoying to read because it's not clear what those indices refer to. In contrast, with built-in tuple support, we can name all of the tuple components and get nicer syntax for creating tuples. This can also be used to improve the calling code. Of course, tuples also have some drawbacks. For example, due to the positional representation, we can sometimes confuse the order of elements. They are not a very abstract representation. When you add new members, you will usually need to update all uses of the data. Therefore, it is often best to reduce the use of tuples in library function interfaces. Ideally, packing and unpacking should be close to each other. Tuples shine the most for ad hoc packing and unpacking of data that is not very closely related. At DConf last year, Robert gave this example in order to argue that we shouldn't add tuples to the language. Basically, latitude and longitude get flipped between definition and use. However, this is not a new issue. D already has this in its dual form. This code is bad code for exactly the same reasons as the previous code was bad code. The same design methods and solutions apply, and I, for one, am happy that we have multiple function arguments. So then, how should you use tuples? You should use tuples for plumbing, for example, to create ad hoc groupings when calling into generic code. Especially when type deduction is useful, so when you want to stick a range into some sort of aggregates, it can be really tricky to figure out what type this range actually has. For very localized data structures between a function or in small scripts, tuples are very convenient. They are also useful to return multiple values that are not directly related. A good rule of thumb is, if it can be in a function argument list, it can also be in a tuple. Somewhat related to tuples, the alias sequences, they used to be called type tuples. How this works is that if you have a variadic template, you can refer to the list of variadic arguments by this identifier here T. An alias sequence consisting exclusively of types can be used as a type in a declaration. This declaration here will declare 3 variables and put it into a new alias sequence S. The 3 variables are initialized with 1, 2, and 3 respectively. A peculiarity of alias sequences is that they automatically expand into any context. For example, if you use it as an element of a dynamic array literal, as we see here, then this array literal will actually have 3 elements, and the values will be the values of the 3 variables in our alias sequence. This also implies that the alias sequences cannot be nested. Those 2 occurrences of S are independently flattened into the argument list to alias sec, which is then further flattened into this array of 6 elements. Some further peculiarities of alias sequences are that you cannot take the address of an alias sequence and you cannot return an alias sequence from a function. Alias sequences can be indexed with a static index, which gives the respective component, which here is a variable. We can use an alias sequence to initialize another alias sequence, which would just generate another sequence of independent variables. In summary, an alias sequence can contain arbitrary aliases. If all of them are types, we can use it like a type to declare multiple variables, and it is a useful metaprogramming tool. However, alias sequence is not a tuple type even if all of the arguments are types. This is because it is still not a type. For example, we cannot do something like this where we want to put 3 pairs into an array. If those pairs were alias sequences, we would instead get an array of 6 elements. Alias sequences we also cannot use to create ad hoc groupings in generic code. This is because in this example we want to return here this pair of values, but an alias sequence cannot be returned from a function. Alias sequences have some other interesting peculiarities. For example, here this initialization would increment j 3 times, once for each initialized new variable, and we cannot use alias sequences in order to swap, because what this here does is it first assigns v to u and then u to v, which leaves both variables in the states where they have values 2 and 2. Let's have a closer look at what a tuple even is. In general, a tuple is a product type. This means it's an aggregate where we can stick in multiple values, and we can also get back out what we stuck in. In summary, a tuple is no more than the sum of its parts. This sounds a bit like struct, and this is essentially correct. For example, in Phobos we have standard type const tuple, which is essentially implemented like this. Essentially, this is a variadic template that expects a list of types, which is then used as the types of the fields of the struct. There is a constructor function, which is just needed so that we can deduce the types of the arguments, which would need to be explicitly provided to the type. Therefore, this struct tuple is a good place to start if we want to improve support for tuples, because if tuples are a special kind of struct, then tuple features become more broadly useful. Every struct can use them. Existing generic code can already handle tuples because it can handle structs, and the calling convention for tuples is already designed. Let's talk about limitations of structs that make them bad tuples. One thing is that we cannot put everything into a struct. For example, this in-out parameter here cannot be put in a tuple because a struct cannot have in-out fields. This is not great, but probably we can add tuples before we fix this. Long term, it may make sense to add some sort of parametric polymorphism in order to support fields like this in structs. A somewhat related issue is that we cannot preserve the lifetimes of variables if we stick them in a tuple and want to get them back out again. I think similar to before, this just means that DIP 1000 should probably be improved. In general, interaction with tuples and function calls is a good benchmark for type system features. Here is how alias sec fares in those 2 examples. The first one doesn't work because we cannot return it, even though we can declare local variables that are of in-out type. And for the DIP 1000 example, it actually works. One big thing that is missing is unpacking, as we've already seen. In this example, we're creating a tuple with 2 components. One of the components is also a tuple. The over 3 components we would like to get out of the tuple and give them nice names. This can be expressed via unpacking like this. If we want to achieve this in the current language, we have to manually index into all of the components in order to give them names. This is annoying manual labor that, in my opinion, the language should handle, and also here I actually got it wrong. People often opt to not declare those new variables at all, and they will just write those indices every time they want to access the components, which makes tuple code unnecessarily hard to read. Actually, in 2011, there was a pull request that did something that's quite similar to what I would like to see now. However, Andre and Walter shut this down, citing worries that it might paint the tuple design into a corner. In particular, Walter would like to see a complete tuple design before committing to this one aspect of it, namely unpacking. Unfortunately, 11 years later, we still do not have tuple unpacking. In my not so humble opinion, it would be good to have unpacking. One worry was that the standard tuple literal syntax would clash with the comma operator and the parenthesized expression. Suggestions to fix this included using curly brackets, angle brackets, square brackets, absolute value operator, banana brackets. There was also this suggestion, interestingly, this one, and I'm too lazy to show the Unicode suggestions. Of course, this is a big obstacle to the adoption of unpacking syntax according to the full tuple design doctrine, because of course unpacking should use the same syntax as the tuple literal. Note that one of those obstacles is gone now. Comma expressions have been deprecated for almost 6 years now. Of course, if you ask Verifile, all we really need is unpacking. So let's have a closer look at Kenji Hara's proposal. Those are examples from his pull request. The second line looks a bit like declare variable x and assign to an existing variable y, which is not what he intended. For him, this is two declarations. Other than this minor issue, I would say slightly generalize it and ship it. Interestingly, back in 2012, Andre agreed that if unpacking is the main issue, we should just add unpacking. And I really do think that unpacking is the main issue. To support this claim, let's have a look at Verifile's example again. This is that example if we only add unpacking features. All that is different from the full example is that we have to manually call the tuple function. And without unpacking, it's decidedly uglier. But in fact, Kenji Hara slipped one case of tuple unpacking past Walter and Andre. Here, this is not an example of that. What this means is that x is an index into the array A and y is the value at each index, which will be printed like this. Note that I really don't like how this is printed. It prints the type of the tuple every time, which clutters the output a whole lot. However, if we map the array through the identity function, then this is actually a case of tuple unpacking, as you can see in the output here. This kind of tuple unpacking works only for ranges. I have also been working on and off on an implementation of tuples. Both the dip and the implementation still need updates, but unpacking should be viable soon. So why am I not done? For static for each, I did it quite quickly, and this was just because there was a very small design space. Everybody was already on the same page what it should do. In contrast, for a full tuple design, there are many moving parts, which makes it more political. It is also a more interesting language design problem because it has to fit into the existing language. Unfortunately, different syntax preferences still exist. The standard, I think, would be this one, which now can be used as the comma operator has been removed. This is, however, more tricky to integrate with function parameter lists. Dip32, also by Kenji Hara, proposes curly brackets instead to avoid the comma operator clash. This clashes with delegates instead, but one benefit of it is that we can have this unpacking lambda syntax. Some other people want to reuse square brackets, which would break this array literal. This is the unified tuples and arrays camp. As I mentioned before, deciding on a tuple literal syntax is a blocker for unpacking, even if we never add tuple literals. Let's have a quick look at this unification of tuples and arrays proposal. However, I think it falls apart really quickly. It doesn't really work because tuples should slice by value and static arrays are already built to interoperate with dynamic arrays. For example, this array of two values, if sliced, produces another array that refers to exactly the same values. If, however, we create a tuple of two values and then slice that, I don't think that should create a dynamic array, and it's not even possible to create a dynamic array if this is a heterogeneous tuple. And then also, what should this mean? Now, this syntax requires homogeneous elements, and this is already valid and creates a double array. Dynamic arrays are reference types, array literals are dynamic arrays, and heterogeneous dynamic arrays don't seem to make all that much sense. Therefore, I think we should really use the standard most widespread tuple syntax with parentheses. because it no longer clashes with the comma operator, and even if it were possible to unify tuples and arrays, it is still good to have different syntax for homogeneous and possibly heterogeneous lists. It also matches function argument list notation, which I think is a more important thing to unify. So for example, the existing tuple syntax is already similar to the tuple literal syntax that I would prefer. And by committing to this syntax, we can pull the most basic unpacking support today. Of course, even with my preference, there are some challenges. For example, the single element array is this, but this is a parenthesized expression. Therefore, we can just write a single element tuple with this trailing comma, which works nicely, also with unpacking. Another challenge is unpacking argument lists. For instance, here we map a list of pairs over a function that accepts 2 arguments. And it would be nice if this just worked, but by default, unfortunately, without additional language design, it doesn't work, even though 2 arguments look really similar to a pair. Another option is to just require manual unpacking by adding an additional pair of parents. This then no longer accepts separate arguments and only accepts the tuple case. One issue with this is that it's unclear what should be the type of foo, and it is hard to actually make this work with the Phobos tuple or similar struct. Another issue, of course, is that this is really ugly and not satisfactory. Another option is to just expand a tuple by 1 level whenever we call a function with it. But then one issue is that it would no longer be possible to call a function with the type of a tuple as just the tuple. The original way I addressed this was to use alias this in function argument lists. So basically this way, if there is no overload that accepts a tuple, the tuple would be expanded and the call would be read-write, which allows calling a function with multiple arguments or a tuple, but it does not allow calling a tuple function with multiple arguments. In summary, what this does is it expands tuple via alias this exactly if needed. A big issue with this, of course, is that Walter does not like alias this. Another issue, of course, is that I implemented it and it broke Phobos. Consider this range of 1 element tuples. It should not have L-value elements. However, with alias this, it would allow implicit expansion. And for some reason, even if r.front is an r-value, r.front.expand is an L-value in D. This is only the issue that I ran into, and so in summary I would say Walter is probably right that we should not use alias this for this purpose. Hence we'll need some new feature. I will call it op-args, and it turns a tuple into arguments in an argument list. The idea is that expansion would be symmetric at the declaration side and the call side so that all the combinations work. One issue with this is that we also need a way to disable expansion in case somebody actually wants to overload on a single tuple argument. We can use a trailing comma to disable expansion, which has a consistent meaning with single element tuples. One issue with this is that it is a priori unclear how much this will interfere with generic code. However, overall, this design would allow a consistent unification of tuples and function arguments, where parents and commas have a consistent interpretation. Another potential issue is with implicit function template instantiation. For example, here we have this variadic function foo, which we can call with a tuple or with 2 separate arguments, and those will just be the same template, and this is not a big issue. However, for bar, there is only a single argument. And now, with the new design, we could instantiate this t to be a tuple type, and then we can actually call bar with multiple arguments. And this is a potential change in behavior for overloaded functions. I do not have a fully fledged out design for this at the moment, and I am not sure how severe the breakage is, but maybe we can put it in addition. Another issue is that expansion is sometimes not desired, and so by default, if we write out the tuple, we will get this. And we would have to explicitly disable expansion in order to print the tuple with tuple syntax. Maybe we can fix this by adding a specific overload to WriteLine. There is an example with an identity function in order to showcase the uniformity of the proposal. Of course, we can always add more parentheses and it will mean the same thing, and in this case we wouldn't need op-args anymore. Note that the usage of trailing commas is a breaking change. In general, trailing commas are already valid and completely ignored, so the usage for the one-element tuple case may change the behavior of existing code with the op-args proposal, though I do not expect a lot of code like this out in the wild. Recall that without op-args, there's also the ugly proposal with double parents and the ugly proposal with curly brackets. Of course, we could also simplify at the cost of getting a bit closer to alias this by making op-args only influence the call site and making it be used if and only if a single tuple argument is passed to a function that expects more than one argument. So leaving unpacking, let's consider again a tuple literal syntax. And one reason why one may want it is not that obvious. Consider this simple example where we create a tuple of 2 ranges and then write out a range of 2 tuples. What I wanted to print is a simple representation where square brackets represent ranges and parentheses represent tuples. As we have already seen, this is not what we get with Phobos, because Phobos also prints out the type of all the tuples. So here what we are actually looking for is buried inside this output string, because the types are so unwieldy, because these Phobos ranges get constructed as composite templates. But in fact, this is not even what it prints. In reality, it doesn't print anything that's useful. So here's the output in its full glory. And the reason why this happens is that somebody put const on tuple toString, which I think was a mistake. Perhaps part of this can be fixed in Phobos version 3 without any language changes. Another thing that would need to be decided is how to denote a tuple type. The most intuitive and convenient syntax that I've seen a lot of people use is to just write it like you would write a tuple of types, which I also think is the main drawback of this approach. Then we could invent some new syntax that is a bit more principled, that looks a bit more like the ML syntax. The issue with this is that it's quite unintuitive and not that easy to parse. And of course, we can also say we will not have a specific tuple syntax. And the pro is, of course, this is unambiguous and works already. And the con is that it is verbose and may clash with the Phobos tuple. One issue with the most popular tuple type syntax is that for the empty tuple, you get the same syntax for the expression and the type. And so it's not clear what this should mean. A possible solution, of course, is always to keep it as an expression and turn it into a type if needed. And of course, the big issue with this is that it is magic. Another issue with the syntax clash is that things that you may expect to work do not work the same at type and expression level, because a tuple type is not a tuple. For yet another consideration, consider this mock vector that also screams when it's copied or destroyed. Here is some code that uses those screaming vectors. We create 2 vectors, we fill them with values, we return them, and we unpack the return value. Ideally, with the tuple syntax, this should look like this. And what we want is that those vectors never scream until they get destroyed exactly once at the end of the main function. However, what we actually get with Phobos tuples is this. The vectors are copied a lot of times and destroyed a lot of times. And those are not copies or destructions of init values, this actually allocates memory. However, note that this is not a pure language issue. Some of those copies and destructor calls are due to Phobos. However, the unpacking use case is important to keep in mind if we want to improve move semantics. In particular, there should be a way to unpack a value into multiple new values while avoiding both copies and destructors. This needs some cooperation from the unpack type itself, because we need to bypass this destructor. My suggestion here is to pull unpacking first and fix move semantics later, except for whatever we can address in Phobos now. Now that we have named arguments, it may also make sense to have named tuples. Here in this argument list, we have names b and a, which swap around the order of arguments to this function foo. We could pull out this argument list into a tuple like this, where we also name the components. And then when we call foo with this tuple and it gets expanded, we would similarly call foo with the same order of arguments. Another benefit of this is that we can address the 2 components of the tuple via their names. I do not have a full design for this, but I think it's good to keep in mind. So what is the state of the implementation that you can find here? I've almost implemented the unpacking declaration. I still need to fix this case where an immutable storage class may be parsed at first as an immutable type. Gehr has addressed this. It's just a matter of integrating this into my code. At DConf 23, I've implemented unpacking for each except for ref tuples. In parameter lists, I have started an implementation. It is not parsed yet. For unpacking assignments, I haven't done anything, but it's quite easy. Op args, there's some basic support that I've used to test things. For tuple expressions, I just forward to TypeCons and also for the tuple type. And for named tuples, I haven't done anything so far. In terms of proposing things for inclusion into the language, I might propose only unpacking at first, and the remaining ideas hopefully sufficiently address this full tuple design doctrine.
All right, thank you for the excellent talk, Timon. And now we are going to start taking questions. Remember, if you have a question for the Q&A session here, please prefix it with a Q:, and you'll be eligible to win a D-Swag item. Also, as a reminder, at the end of the day, at the end of the event, I'm going to be doing another drawing for everyone who asked a question today. If you were eligible for any of the drawings, you'll be eligible for the final drawing for a $100 Amazon e-gift card. So let's see. Ricky had a question for no tuple expand. How's that for right line?
I mean, ideally, it can be solved in some way that's a bit more uniform than that. But I guess in the worst case, you can always do this thing where you just add the thing that does what you want. So it's my immediate reaction to that.
Okay, and Andres, hey, good to see you at a DConf again. Hope to see you in London. It's been a while. Could the desire for tuples be solved by making ad hoc structs a part of the language? A struct is a tuple with named fields. Maybe the name for fields could be optional and structs could be unpacked.
Yes, it's essentially the proposal. I mean, the tuple literal syntax would just forward to some structs. And about named fields, that was on slide 55, I guess.
Okay, and from Serg, we have map array. Can't we make map tuple to make right line examples look nice?
I'm not sure how it would work. So I would need additional clarification on that. So map array creates an array out of a range. I guess map tuple would create a tuple out of a range, but how would you figure out how long to make the tuple and how does it address the right line case?
Okay, any other questions or expansions or responses?
Maybe I get to details. Okay.
Say again?
I'm still not sure, but I'm still not sure what the suggestion is precisely.
How says, I love using tuples in Python, simplifies code a lot. Have you done a survey of tuples in other languages, or?
And not a formal one, but I guess in the meantime, C# has added tuples, and it's essentially a very similar design to what I had in mind. So. But I also think it's quite canonical to some extent, but then still there's people who would like square brackets, people would like curly brackets.
Right.
That kinds of stalls it.
Okay, another question from Andreas. May it be possible to have an explicit unroll syntax instead of a calling function with tuple values to distinguish passing a tuple or using the tuple as arguments?
Yes, I mean that's essentially what you have anyway. The issue is that this is really annoying to use in a higher order function context, like when you use Phobos ranges. Then you would have an additional like lambda in between that has to explicitly unwrap the argument, and you kind of I mean, it just makes things harder to read, which kind of offsets the benefit of the feature in the first place. Of course, what you can do is do double parents and just unpack it in the parameter list itself.
Okay, going back to... Oh, I'm sorry. Go ahead.
Yeah, but I mean, the issue with that is that then the nice unification between like parameters and unpacking kind of dies. I mean, this is how multiple arguments work in most functional languages. And I mean, it's kind of desirable to get that. Maybe we can't get quite there, but there would be options to do it. It's just a question whether it's worth it.
All right, going back to Serg's question earlier about the map tuple thing, he said, I meant .array eliminated map results things. The original question was this one.
You mean in that? Okay, you meant in that example. Yes. I mean, you can work around it because you can write a const array. You cannot write a const range because you cannot use a const range for anything. And because const is transitive, you can also not remove const from a const range in general. So code kind of has to give up and cannot print it anymore. Which is why I think const should not be added unless it is actually on the toString of all the tuple components.
Okay, and we've got a comment from Walter. Can you make this talk into a paper?
I don't think so. It's probably not any kind of novelty. And nowadays, programming language researchers do not even add tuples with more than 2 elements to their toy languages. So probably the first thing that would be suggested in a review is why don't you just reduce to tuples with 2 arguments? Why don't you ignore the single tuple case, stuff like that?
Yeah, Walter says it's too much information and he wants to study it.
I mean, I have, okay, for you, okay. Yeah, I mean, I guess that's the point of the dip process.
And it's not a question, but a comment here from Max. Implicit unpacking and call expressions strikes me as the kind of thing that would bite in a big code base. For example, things like toStrings and write lines in particular can silently change in the background, even in a statically typed language.
Yeah, well, I mean, I guess the question is how do you think about it? And the proposal is not really, the unpacking is just a mechanism. I mean, the proposal is to basically say every function has 1 argument, it may be a tuple, and existing functions that have multiple arguments just have a tuple of arguments, but with existing API. That's kind of the thing that the middle one of the 3 proposals was trying to do. And then it's actually uniform, but of course some generic code could be caught off guard by it, and I agree. So trade-offs. I did have another suggestion where it's basically just only done if the function you're passing something to must be called with more than one argument. And maybe that's a bit less likely to blow up and still useful, but also less uniform.
Okay, last call for questions. I've got 3 names on the wheel of names. Is there another? And while I'm waiting for a response there, Timon, why don't you give us any closing thoughts you might have before we call it?
Well, I mean, I would like to see unpacking in the language, and the only obstacle to that, I believe, is deciding on which kind of phrases to use.
Mm-hmm.
And I would be happy if you could just decide on parents, which is my preference. But of course, if Walter wants to overrule me and put square brackets or curly brackets, that also works for me.
That sounds like a fodder for an epic forum thread at some point.
Yes. I mean, not. I mean, yes. At some points in the past, I mean, I think there's at least 2 of those.
Yeah, they will probably.
But nothing came of them.
All right, we do have a question. One more question, and it's going to be the last one. Ricky, your name's already on the list, so not a new name here. But will we be seeing an idea thread summarizing tuple unpacking soon? And I guess he means in the new Dip Ideas forum.
Yeah, sure.
There you go.
I also have to work on some papers. The issue we usually run into is that we do too much engineering and then you have to explain it, and it doesn't fit into a paper.
And Walter responded to your use parentheses.
Nice.
Done.
Yeah, let's do that.
All right.
It's
decided. And with that, I'm going to go ahead and pick a winner. We have 3 names, and here we go. Serg, congratulations. You are going to get some DConf swag, and I will get in touch with you on Discord, or you can ping me, whichever you want to do. I'll let you know what you need to do to claim your prize. And with that, we are done with Timon's talk. And next up is Mike Shah. And thanks a lot, Timon. And I'll see you in a meeting soon. All right, and we are back, and Mike Shah is with me, he of the graphics teaching and programming. So how you doing today, Mike?
Doing great. This has been an awesome conference, lots of fun, and one of my favorite. There's no pressure today. Everything's pre-recorded too, which is awesome.
Yeah. Speak for yourself. But no, this is actually pressure-free for me too, in comparison to the real world DConf. I know that. Yeah. So your talk today is another graphics talk. This is a theme for you at DConf. This is your third one now, I think. Your third talk. Fourth. Yeah, because you've done two in the real world, and this is your second online talk, right? Yep. So the case for graphics programming in D. So you've done 3 talks about graphics programming in D already. So now you're kind of like, this is like going to the beginning. This is like the prequel almost. Right. Yeah. So what brought this on? Why this?
Yeah, so I've been teaching graphics a lot, real-time graphics in C++. As you folks know, I've done non-interactive graphics with D, but again, as I use the D language more and more, there's just a case for the productivity, the fun of building graphics applications that I wanted to try it out in real-world graphics. And I was wondering why more folks weren't using it. So was there something like inherently difficult or anything? And I think you're going to find out the answer is no. I mean, people should try and give D a go with graphics programming and see if they're more productive and if it meets their needs. So that was kind of the impetus that prompted the talk to just get something out there and see, like, if I'm doing it, you can too, and you can probably do it better with the D language.
Well, now that I think about it, your last talk was not graphics related. It was about teaching D. So has that... can you give us a follow-up on that? I mean, I know you mentioned that you were interested in talking to other teachers and anything you can say?
Yeah, so I'm actively recruiting. If there's any professors out there who want to teach software engineering in D, please talk to me. Still actively teaching D at university, still distributing my materials and thinking about how to put all of my most recent software engineering lectures, which were in D, online. I'm figuring out what a mechanism might be for that. But it went through another semester teaching D with software engineering, and students were doing gaming related projects as well. And again, great results. The students are able to do more, work better in teams. I mean, everything is just at a nicer level. I mean, and I think the language and the ecosystem has something to do with that. It's there will be more follow-up on that, and there will be more teaching coming up this summer. I'm not going to announce everything yet, but maybe a little spoiler for folks attending DConf here, that I am going to be teaching more classes in graphics using D.
Oh, that's great. And, I kind of thought it was a pretty fun that you brought your students along last year to that. I was surprised by the proposal when it first came in, pleasantly so. I thought it was a great idea. Any plans to do that again this year?
I'm gonna open it up to students. I don't know. We'll see. I'm always pushing for them. I think it's great to get them out and see what all the other folks are doing at D conference and all of you professionals building real world software. So always encouraging them. We'll see if we get a presentation or maybe just some students to attend. Mm-hmm. I kind of want to support this in a similar way that Symmetry does the Autumn of Code and brings in students. So I think the more that we're doing this at university and getting our students excited and presenting their results is great. So if I can, I will bring students. We'll see who signs up though.
Well, that's great. And I hate saying things that are in my head that things that sometimes that I've talked about behind the scenes with people because I don't know if they're going to materialize or not. Sometimes I'll mention, I'm hoping to do this, and then it never happens. But I am going to say this. I'm hoping to get an intern position set up with the foundation. I don't know if we're going to be able to pull it off, but if we are, I think it would be a great opportunity for students. I've already got somebody in mind that I want to get the position for, but I don't know if it's going to happen or not. It's it depends on the funding. Have you followed up with the students from last year who came to London? How are they doing?
Yeah, they're doing great. So we actually, Ali was visiting Boston, so we were lucky enough to get Ali to come back and visit
Ah,
in the fall. And the students came and met again with Ali, and we had a great time. They came back to actual engineering class, and they gave advice to the other students about using D and what they had learned. So they're still, active. I think some of them are on internships doing various things right now, but
mhm.
yeah, hope to hear from them soon more about what they've been doing. But yeah, they were absolutely able to follow up in the fall, and that was great.
Oh, that's awesome. And before we get started with your talk, is there anything you want people to know, to keep in mind while they're watching, or anything you want to say to set it up?
Yeah, I guess just that folks who are doing graphics programming and want to give a try in D should really think about it. And there's been some precedent from this. Ethan, who's part of the community, and you'll see him pop up in my talk, they've done stuff with AAA games and graphics and their real-time animation system. And I think folks should give D a try for graphics. Maybe it's just because there aren't a lot of talks about it, but here's one of them, and you'll see the D advantage in my view on this.
Okay, great. And I actually, before I jump into the talk, I just have one more question for you. I forgot to ask it earlier. What do you think, is D missing anything right now that would be beneficial for graphics programming?
It's interesting as I think about this because graphics programming today, especially, is so GPU bound.
Hmm.
Once you get the data on the GPU and do something interesting there or in some compute platform, the CPU side of things is where things are interesting. So I think this is where D is interesting on the concurrency side. If we figure out things with shared and the sort of safety and getting that pipeline set up,
Hmm.
maybe that's a direction to push on.
Hmm.
Um, but I think all the tools are there already for folks who do want to build interesting graphics applications,
All right.
whether it's
That,
games or whatever. Yeah.
yeah, that's great. And I will go ahead and start the talk right now. Yeah, I say that without my mouse in my hand. There we go. All right, here we go.
Enjoy it, folks. Welcome, folks, to DConf 2024. I'm excited to be here. My name is Mike, and I'm going to be your guide today talking about the case for graphics with the D programming language, why I'm using D to do graphics programming, and why it's a feasible option for doing real-time or non-real-time computer graphics. Today, we're going to talk primarily about real-time computer graphics. So with that said, let's go ahead and dive into it. I'm just going to show you some demos so you can decide if you want to stick around or not for the rest of this talk. And the first demo that I'll actually get running here in the background is a demo here with a famous Stanford bunny. Here it is running in a window. And what's special about this demo is I'm actually rendering all the geometry and everything to texture behind the scenes and then pasting that texture on the window. So of course it looks 3D, but it's actually just the 3D data that we're capturing here on a 2D image. So this is an advanced rendering technique for things like deferred rendering and many of the cool effects that you see in games today. So anyways, I've got some sample code for how to set that up using things like frame buffers to create multiple rendering targets. So that's what's special about that demo. We'll see that towards the end of the talk. In the middle of the talk, we're going to see, well, the same exact image that you just saw here. But I want to talk a little bit about how I use the D programming language for structuring and parsing data. Because of course, if we want to load cool models like this with data and textures and so on, we need to understand a little bit about that. So I want to just talk a little bit about data manipulation, some geometry processing, the very, very basics, so you can see or understand some of the advantages of the D programming language and where you might get an advantage. And finally, where we're going to start here, demo 1 of 3 here. So the first demo that we're going to see is the classic triangle. And well, we've got to start somewhere. So we might as well start with somewhere kind of simple, understand how to get set up, and understand how well D plays with C APIs, for instance, which many of these graphics APIs are programmed in. So with that said, let's go ahead and get to the goals here, and then we'll dive into the meat of the talk. So my main goal today is to get you excited about trying out D as a programming language for doing computer graphics. Now that could be interactive computer graphics or non-interactive, so real-time or not real-time graphics. But either way, I found D to be a viable alternative to other languages, and it's something that I'm increasingly using more and more. So with that said, that's my goal here, to get you excited about this language where you can write fast, read fast, and run fast. So I'll let you go ahead and read the rest of the abstract. Of course, you've already read that. That's why you're here. But let's go ahead and move on.
So me, your guide today, the guy here in the corner. You could read about my websites and other talks and so on here, but primarily I do teaching, and I do a lot of teaching in computer graphics. So this is a subject that I love, and of course I'm happy to talk to you about. And the code is going to be available for this talk. It's already uploaded on this GitHub repository. I might improve it over time, but feel free to take what you have, and you can compile and run those demos that I showed you at the start of the talk. So let's go ahead and dive into the slides here. And let's talk about the case for the D programming language. Well, the case before I got to it. In fact, this is an article written by Andrei Alexandrescu, who is somebody who's worked on the D programming language, as well as being known for working and writing many great C++ books and articles, and giving many great talks on software development. But 15 years ago, Andrei wrote this article here, The Case for D, where I inspired or took the title of this particular talk from. And he talks about it in a really nice way, but summarizes his article finally here by saying D could be best described as a high-level systems programming language. So again, think about a systems language, something that allows you to allocate memory, have control of pointers and low-level access, bit fields and shifting of bytes and so on, all the fun stuff that we really like to use. But it's also a high-level language, meaning that it allows us to be productive. It's got built-in data types, such as things for associative arrays or dictionaries in other languages and dynamic arrays. So there's really a nice standard library and built-in data types to complement the system side of things. So we get the best of both worlds here. As well as it being just a modern programming language, you can look at all the features here in the spec, but just to highlight a few, again, D is compiled. That's where you get a lot of the speed from. It's statically typed, so that's where we get a lot of the safety from. It plays well with other languages like C, C++, Objective-C. We're going to find out there's a really cool compiler built in or embedded in the D compiler called import C, which allows you to just literally drop in your C files and use them as is. So you can transition your code to D if you want, or mix C and D code pretty easily. There's also interfacing with other languages, as I mentioned. There's a bunch of modern features as well for productivity or expressivity in your code, or for just writing more maintainable code that we'll look at here. But things like ranges, compile time execution, slices, lambdas, mix-ins, contracts, and so on are just a few of the features in the D programming language that are particularly interesting, I think, for a graphics programmer. So the case for a D programmer, as well stated by me, is the following here. I mean, if we want to use a language for doing graphics or maybe game programming, something that's very demanding of performance and doing things at real time, generally speaking, we need a systems programming language that gives us control. Of course, we could develop without a systems programming language, but generally some sort of compiled language that gives us access to low-level features is a good idea for doing graphics programming. Again, it's a field that demands a lot of performance. And many of the graphics APIs, such as OpenGL and Vulkan, they are C-based APIs. So working with D, which plays nice with C code, is a good thing. Again, D interfaces very easily with C, following the same code layout and the calling conventions. So that's very much a nice thing, and it's very likely if you have some C code, you can almost drop it into D and start using it if you need. And then there are, of course, some things that we need for graphics programming, such as a math library or the ability to make a math library. Again, we've got nice features like operator overloading if we're going to build our own library, but there are some libraries included in the DUB, which is the package repository for doing graphics programming. So the case for D here, most of the defaults are right. In the D programming language, you get things like variables that are initialized, but you have control if you want to allocate a large buffer and not initialize it for speed. Const and immutable are transitive, so again, it's hard to break guarantees about your code if you want something to be read-only. That becomes particularly important when you want to write concurrent code, again, something very important for performance and graphics. Casting must be explicit, so again, for safety, it's easy to see in your code when you've casted something, and that might be a warning sign for, paying a little bit of extra attention. The D language also allows you to or rather the D ecosystem, I should say, the DMD compiler, as well as the LDC and GDC compilers, but in particular, the DMD compiler is very fast as far as generating code and allowing you to run an executable. The D compiler as well allows you to write fast code. As I mentioned, it's a system programming language, but you have access to things like the SIMD libraries. You've got various multitasking support things like threads and fibers and so on, message passing, which you can make concurrent. Again, different strategies are available for, again, getting a lot of performance. And of course, what's important here is, well, it's fun to write code in D. That's my personal bias, but again, I'll try to show you why it's a fun language to work in. So anyways, with that little introduction about D, some of the language features to get you excited, let's go ahead and take a look at what it means to render that first triangle here. So again, a nice triangle here. So in order to get things running on our graphics card, because we want to be able to take advantage of that nice piece of hardware to draw things fast, we need a window, we need to set up OpenGL or maybe some other API like Vulkan, and then upload data from our CPU to our GPU. Those are the basic steps that we need to think about. And then of course we need to write a graphics pipeline, which we'll get into the shader part here. But let's go ahead and look at these steps here. So in order to set up a window using the D programming language, usually we want to use some library because this takes care of some of the nitty-gritty details if you're on Windows, Linux, or Mac, or some other operating system for just setting up a basic window. Now, of course, you can access the native windowing library if you need, and there have been people who have even figured this stuff out for Android or iOS as well. But the packages that I most recommend are going to be the bindbc for GLFW or bindbc for SDL, and you can use dub to install those dependencies relatively easily. They just work and they're kept up to date by Mike Parker. So what these packages are basically bindings that wrap around the C libraries GLFW and SDL, which are again written in C and talk to whatever operating system you're on to basically just open a window, handle events, mouse clicks, and some of these basic things. So once you have a window set up, you can start getting into some graphics code. Now, what I'm actually going to show you behind me here is what those bindings are doing. They're doing something like this, where you have an extern C to talk about the calling convention, and then basically just wrapping those functions into this block here so that we can actually just call into a C library that we link in. So I'll go ahead and draw your attention to where my cursor is, where I want to link in, say, the GLFW3 library, which again is primary purpose is to just create a window. And then we can just link in that library with its location and the actual compiled C library, and then just make calls here. Now, again, those previous packages, if I go back a slide here, will do that binding for you. But in case you want to know how to do this manually, or use some other library that you have that exists, or maybe there isn't a package for yet in D, this is basically how you do it. And I've done it in the demos that I'm going to be providing you today, just so you can minimize your dependencies if you don't want to use anything else. So as far as the next step for doing graphics programming, usually you need some way to load functions for the graphics API that you're using, or the extensions, because we've all got different graphics hardware with different capabilities. So usually this is something that, again, we might dynamically load when we launch our program to figure out what features do I have from OpenGL or Vulkan and so on. So I opted to use a tool called GLAD. You can see the configurations here that I use to generate basically a binding to all the different functions that I can call using the OpenGL API, and they've been set up so that you can use the exact same types that I use in the D programming language. So here's what that actually looks like in practice. I'll again move out of the way here. We first have to import GLAD, which is the GL library for loading all of our OpenGL functions. And then somewhere in our code, when we're executing, perhaps somewhere in our main function or nearby, we call this GLAD load GL function, which loads all the OpenGL functions for us. Now, immediately what we see, and is kind of interesting here, is that we're using import, like you might have seen in other languages like Java or Python and so on, and is also coming to C++. But this is something that's been around in D for a long time, this module system. And by having modules, we don't have to mess around with header files at all. There's no preprocessor, and compiling the individual modules is something that can be done very, very fast. The module system is a great way that we can compile our code quickly and iterate, which again is super important for software development. And again, one of the reasons why I like working in D. There's also little quality of life improvements For instance, if I move forward, where you don't have to worry about the order that you have the functions listed, you don't have to forward declare things because, again, in a modern compiler, we can have modules where we look through things. So again, these are just some nice to have things here. But we'll also notice here is, remember I talked about in that previous step here with the box that's highlighted here, that we have to set up OpenGL before we use it. So what we can actually do here is in a module, use a module level constructor here. And you'll see here I have the shared static this here, which is basically a module constructor for this file here where I can do all of my initialization code. This block here, or this function, will be called in the module before the main or entry point of our program where we can do any initialization. By making it shared static, this will just be called once, even if I have a bunch of threads executing at this point in my program. So that's the basic idea here. I have a very clear point where I can do my initialization, which I found, again, in graphics applications, I have to do a lot of these little setup steps. So it's just nice from an organizational point of view. Now, as far as the graphics pipeline goes, when it comes to programming here, here's a really simplified model of it, where we have our application stage. This is what we do on the CPU. We have our geometry and transformations, and then we have our rasterization and pixel processing where we color things in, and then ultimately we display things into the screen. So again, this is just a really high level overview so you can follow with some of the different things that I'm doing or otherwise get you excited about graphics programming. So again, the application stage is just, our code here, our D code that's just executing on the CPU. And this is where we handle things like the file IO, like loading data files with 3D geometry that we're eventually going to render. And when we get into the geometry stage, this is where we're actually going to create or form, based off the data that we've loaded, the different primitives like triangles or other types of primitives, and transform and orient them in our scene. And then we'll color them in, which is this rasterization stage, which is basically just a fancy word for saying when we have a triangle here, I need to figure out the pixels on my screen that approximate a triangle to the best we can, the discrete steps that we take, and then shade them in, just like a coloring book. And then finally, we display whatever our 3D model is. As you can see here, this rendering of a cow or something that's being set up here in something called a frame buffer. Frame buffer being something that I've used before that term, and we can have one or multiple images being captured at this point. So with that said, let's go ahead and proceed forward, and let's look at the code for displaying a triangle. Now, I'm not expecting you to read all this here, but a few of the observations that I want to make here, for those of you who have done any graphics programming, this is essentially the same code here. I literally copy and pasted from my C++ project here and just changed a few of the types here and where a few of the brackets went. That was pretty much it. So it's a very easy transition into my D code. But some interesting things about using D for graphics programming here as we move forward. There's one small little change here, this sort of get out of trouble thing that I often use here, these little pragmas here. So I'm able to put a message here about my data here, which is my vertices that I'm going to use to eventually draw a triangle. And this actually runs at compile time, which I found to be just another one of those invaluable tools to be able to do printf debugging, but at compile time. So before my program even runs, to be able to gather some information and test my assumptions to see if things are working. So in this particular case, just a simple check of the length of my data to make sure I have a even number of data pieces here for my particular triangle that I'm trying to draw here that we'll see in the screen in a moment. And there's also some other nice things that you might notice here that are different if you're coming from a C or C++ world, is that on this M vertex data, there is a dot length here. So any of my arrays here, I can actually check the length here, which is really nice to be able to carry both the pointer and the length with the type. And this is something that we might have seen in modern C++ with their standard array, but we have that in D, which I think fixes a lot of different mistakes in different programming languages. And these arrays can also be bounds checked automatically. You can turn that on or off if you need, but again, just little quality of life improvements here. Some other things that are also handy here to note is that while I was preparing even a simple triangle, I often got this sort of dark triangle or triangle without color here. And this would often be a mistake of different things that I messed up, like missing a comma here, just little programmer mistakes that you make. And D also has static asserts that you can also catch at compile time, again, which are very useful. I've used some of these static asserts for things like this. You'll observe there's capital G, capital L, and then lowercase float, and then there's an enum for capital, all the capitals, GL underscore, capital F, capital L, etc. here. And those are actually different types in OpenGL. One, again, is an enumeration from a C library, that's an int, and the other is an alias for a float. So it is nice to have those static asserts to check the actual data type sizes, again, as you're allocating memory. Now, of course, in D, the basic types have predictable sizes, which is just something that's really nice, again, so I don't have to think between the different architectures. I know a float is going to be 4 bytes, for instance, or an int's going to be 4 bytes as defined by the D language. So these are, again, just some nice little quality of life things. I can still write those static asserts for my own sanity check or to make sure with any C bindings that things line up. But again, just nice little things that I don't have to worry about. Again, in this code here, so right above me here, you'll notice that there is a cast. And you could read that, tiny keyword here. But that's basically just saying that all the casts in D have to be explicitly made. So you have a keyword for that, which is very nice. Again, some languages are starting to introduce these things, like in modern C++, you have your static asserts, but it just makes things a little bit nicer so that when we're casting data, as we often do from client to server on the CPU to GPU, in other words, as we pass data back and forth, we know the exact type that we are casting to. Okay, so with that said, that's just kind of a little crash course into rendering a triangle and just a few of the quality of life improvements, again, that go on in, what's only 10 or 12 real lines of code here, which are responsible for allocating memory on the GPU, passing that data to the GPU from our CPU, and then setting up the sort of layout of what information we're passing in. Are they vertex positions? Are they colors? How many floats of data do we have? And so on. So that's the basic idea, again, of all of what this code's doing. So that's one piece of the puzzle, however, for doing graphics programming or getting started. The other piece is how we, shade in or color in our data and transform our data, which are handled in sort of this geometry stage or something known as a vertex shader. And then here where we do pixel processing and what's known as a fragment or a pixel shader. So let's go ahead and take a look at these programs here and some of the nice things that we've done here. Now, again, here's the full sample code. I'll move out of the way so you can see it for building a graphics pipeline. Again, that tells us how do I take geometry, transform it, and then color it on the screen. So we get a programmable pipeline, a very powerful thing, but there are some setup stages that we have to do here. So what are some of the quality of life things that we get from the D programming language here if you're a graphics programmer? Well, the very first one that I want to show you here is I actually didn't load any files here. I just imported and mixed in this code from my shaders, which again are separate tiny programs that we compile into our graphics code. And this is like in C23 where you're going to get embed, which is very nice. It's nice for prototyping. It's also a nice way if you want to compile in data into your code so that perhaps someone doesn't have access to change that file. So again, there's a few different benefits to this. And, for someone who's just getting started in programming, you don't have to worry about loading files and parsing errors. You just read in the whole file and there you go. And now it's stored as a string. So that's one little quality of life improvement. Now let's start talking about something more interesting than one triangle and rendering many triangles so we can compose them and build something like this. This bunny here, again, the Stanford bunny. So let's say we want to parse some structured data here. And basically what I have here is, all the parsing that I need to do of a file. And I'll show you what this file format looks like in a moment. But again, let's talk about some of the advantages that I was able to use in D here. So first and foremost, you'll observe that's available in D, the universal function call syntax here, which really shines. It allows us to write really concise code for splitting a line, converting it to an array, removing the first element of that array, and then processing each of the elements that we've split up here, in this case, vertex information, and then parsing that data into an array to store all the individual vertice coordinates. That's all happening in one line of code. It reads left to right. It's very readable, very maintainable. I like being able to do this. So just as an example, you can see on the left is an example of the C++ code when I first wrote this many years ago, and the example of D. Now, as far as these code snippets go, they're about the same amount of lines of code. This one, the D one, because of the universal function call syntax, I'll argue it reads a lot easier. It's easier to maintain. In fact, it has a little bit more as far as what this code is doing. In fact, if we look carefully, really these first two if blocks here are doing most of the work of all this code here. So it is in fact much more concise as far as just parsing a data file into individual vertices and other attributes that make up this bunny that we see in the top right here. So again, this is just something when I was writing this code, I started pondering about, and a few months ago, I knew I was going to give a talk on this topic, or at least submit for it, because I just found how much easier it was, the quality of life improvement for parsing and working with data. So even if you don't want to use, say, D for the main tool for your graphics programming, using it as a tool for the actual digital content creation pipeline could still be very advantageous, or building tools, for instance, in D. So again, that's what I found here. And I'm kind of leaving it as an open challenge for folks, myself included in this challenge, to take models like this bunny here, which are stored in the OBJ or object format, and seeing how fast can you parse it, in particular using D. I think with D's concurrency features that we could actually probably beat many of the fastest object model parsers with relative ease based off of some of the facilities here, or at least get something close to some of the top parsers. Okay, so let's see what tricks we can pull out, and I'll leave that as a challenge now that you have some of the base code to do this. But anyways, I was actually able to extend my parser just a little bit more, and I'm just giving you this for context here. I'll make it a little bit bigger. The code so much isn't as important here, but what I'm doing with this chunk of code here, again, not too much code, is being able to load multiple models with multiple materials, all with this chunk of code here, and a few structures above here to handle storing the different materials. But what I found here, again, is D scaled nicely, and using a mix of functional and object-oriented paradigms, I was able to improve my parsing code for working with any type of geometry data. So again, if we want to see what that actual format looks like, it's structured as following. We have vertices, a list of X, Y, and Z points, texture coordinates, normal coordinates, and perhaps other points for making primitives here. So that's the basic idea of the types of files we're parsing to get this bunny shown here. Now, something also interesting about that, with that in mind and the different data here, again, having, say, vertices, textures, if we want to put an image on top of this bunny of nice fur or something, the normals, which are what are making the blue, green, and red sort of colors, which sort of show what angles the triangles are pointing to. Something that's interesting is there's actually a combination of those pieces of data. So for instance, there's just vertices. Sometimes you have vertices and normals, sometimes vertices and textures, sometimes all three. And that got me thinking about how could I actually write that code or generate that code, given that one of D's strengths is in metaprogramming. And here's the idea that came up here, basically to write some sort of structure. I call it a flexible vertex format. Sometimes you see these in games here. But you can see it takes a variadic template here, and basically the two different instantiations shown at the top of the screen here take in different structures for maybe a vertex, an X, Y, and a Z point, texture coordinates, normals, or maybe just 3 floating point values, and you could generate, using some of the introspective capabilities, the code for handling vertices, normals, texture coordinates, etc. And you can actually do this with a lot more accuracy after you get things set up and make your code a little bit less error prone. So this is the actual code that I've included in the demo showing two different versions of handling vertices and normals with the geometry data, or vertices and textures. And as you can see here, or maybe you can't see because it's a little bit small, but it's basically a lot of the same boilerplate code. In fact, there's only a few integer values changed here. So why not be able to generate that data by just reading in a struct of the form that you want? Again, D makes things relatively easy. Again, those are things that are accessible in many languages, but the D approach here with this little example shows how you can kind of start generating your own structures and boilerplate code. Again, that's not a full sample, but this is the tiny bite-sized sample you can try, and then you can see the actual layout of the data. Okay, so with that said, let's get to our final demo. And for this one, I just want to make a small point about render targets here. Now, again, demo number 3 is the same as demo number 2, as I mentioned, but the idea is that I could actually render my scene multiple times in multiple passes and then compose them into a final image here. So here's with the normals, here's if I change the normals or add a shadow, and then I could merge in these two images or sort of compose them in the way that you would in Photoshop with multiple layers of images, for instance, and get a final image. Now, graphics programmers will often use a technique known as deferred rendering as well, which is a sort of optimization or a trade-off where you can do a lot of the expensive processing on the final image, like computing lighting and other physical effects. And this in particular has nothing to do with the D language. And that is quite often actually the point that I'm trying to make here, that you have access to the full graphics APIs and capabilities, and all the stuff that's GPU bound is, again, tied to those APIs. But the advantage you have with D is that you can use things like some of those metaprogramming capabilities, the language itself, that's a higher level systems language, to write your own interface to make it easy to generate abstractions for things like render targets. So that's what I provided in the sample code for today. Okay, so that's the idea here. So very briefly, as we wrap up, I want to keep you excited about using D for graphics. And I gave a previous talk on this, but just wanted to highlight a few of the projects here. There's been AAA game projects. I believe the animation system was used with D code here. So you can watch Ethan Watson's talk about that at the Game Developers Conference a few years back on Quantum Break. There's beautiful engines here, like the Dagon engine here, showing off some of these deferred and physically based rendering techniques that are really, really nice. There is other game engines that have been in development. Here's Dash, another open source project, and Hapreme, which is a more recent engine that runs D code on many, many platforms, including the web, different game consoles, and even Android. So that's another nice project to take a look at here. So the last one here is also a simulator, or a flow simulator here for doing various gas simulations and fluid simulations. And I just thought this was another really neat project. So anyways, as far as learning more about the D programming language, you can check out the History of Programming Language paper if you want to find the sort of nitty-gritty details about using the D programming language and how and why some of the features were influenced as they are. There's many resources and tons of video talks and more graphics projects. I've got my non-interactive graphics on ray tracer talks from previous DConfs you can check out. There's lots of great resources on Vulkan as well here, lots of bindings, and many folks are probably going to push you towards Vulkan in the future. And then there's the D language tour if you're just getting started, but maybe have experience in other programming languages. And these are the two books I would recommend for getting started. Any of the D programming language books, to be honest, that you find are great, but these two in particular are wonderful. And of course, my YouTube, I'll eventually add some more graphics resources, but if you're just getting started, feel free to check those out. So with that said, thanks for having me. Thanks for listening in, D Conference. I'll look forward to your questions and discussions later on. And I hope you'll take on my challenge of writing different object loader parsers, seeing how fast you can parse a large or a small object, and feel free to tag me on Twitter if you complete that. Alrighty, thanks for your time and attention, folks, and thank you again to the D Conference 2024.
We go. Hello, everyone, and welcome back to the next Q&A session. That was a great talk, Mike. I was happy to see it a second time. Actually, I guess it's 2.5 times now I've seen it. All right, if you have a question for Mike, please prefix it with Q:. And let me catch up here. Okay, here we go. We have a question from 25th. What is the state of the union for using D for game programming, particularly with Rust being the new kid, while C++ continues to be the standard? Can the future have room for D games?
Yeah, I think absolutely. So I was talking with Mike backstage. I'm actually at the Game Developers Conference right now, so it's going to be kind of interesting to talk with folks, especially in the indie game space, where you're not really forced into maybe a legacy code base that primarily in this games industry and graphics is C++. I think behind the scenes, folks are using whatever language. I mean, people are building games in Python, so there's certainly room for D in the game programming space. I suspect there are folks building games already. We just don't know, or they haven't announced them on the forums. But as you saw from the talk, I mean, there's been AAA game code, and not just on the tooling side, but on like the heavy compute side, like the animation system, and doing really interesting things. So that was from Ethan's talk. So yeah, definitely a room there.
All right, and next one, Mike, do you teach your graphics computer students to use D or C++?
Right now, it's in C++ as of this last term. I've given students the option to use D if they want, and I have had one student take me up on that, so they completed the course. And part of the secret motivation behind this talk is to kickstart me into writing some more D code and graphics. So I am going to be teaching. I forget if I gave the spoiler away at the start already. An advanced graphics course this summer. I'm going to be doing it in the D programming language because, again, less to fight with, hopefully, as you saw in the talk. So there will be some inertia there, and I'm hoping to produce some more D examples, tutorials, and do some cool graphics work in D. So that's the exciting stuff coming up.
Awesome. From Bruce. Hey, Bruce, how you doing? Are compute shaders part of what you teach? And if so, have you tried dcompute?
Haven't. I've talked with Nicholas Wilson about this. Usually I don't get to it in the course. Compute shaders, that might be a thing that folks do for a final project on occasion. So I usually don't get to that point. I do want to do more stuff with dcompute. I do need to talk with Nicholas more about that. But yeah, I'd love to do more dcompute stuff.
And cool dude. Do you see non-AAA studies going for Vulkan when it's an order of magnitude more complex without similar gains?
That's a good question. I think that's why a lot of folks have been leaning into these engines, Unreal Engine, for instance, which have pretty mature, or at least a lot of engineers dedicated to working on Vulkan. I think there's still room for OpenGL, and what's going to probably happen, or what we're seeing happening, is that OpenGL will just get translated in some layer to Vulkan anyways in an API. So that's a good question. I'm certainly going to be talking with more folks about that. I am seeing the industry moving more towards Vulkan, DirectX 12, Metal, of course, on the Apple end. So we'll see. But there is sort of a complexity issue, and it's hard to get, for instance, university students out of school knowing some of these tools. So there is some barrier there.
All right, and Andreas asks, is the garbage collector of D in the way for real-time needs of AAA games and real-time simulations?
Yeah, good question. I probably should have put a slide because this always comes up with gaming and graphics. Since the performance in a graphics application is oftentimes so much GPU bound, it's not going to affect that part, right? The actual rendering in that sense. Most of the time, games pre-allocate everything they need before they start. So garbage collection shouldn't be an issue. I suppose it is, possible. It's something that you would look for when you're profiling, but most games are not allocating. So the garbage collector really shouldn't be an issue. Again, it should be a strength for safety and these types of things. So yeah, I don't. And as always in D, you have many memory strategies. So I don't think that should be a barrier to adoption for the D programming language in particular. Again, it's a strength that it's there when you need it.
All right, and another one from 25th. Does D have a way to pre-process C macros and preprocessor definitions? I'm asking in the context of raylib, even though I am aware there is a D binding. I assume it uses import C. Too bad Steve's not here.
I was going to say Steve's the right person for that question, probably. Let's see here. Let me read that again. Does D have a way to preprocess macros? Maybe. I mean, maybe there's something there with. I know import C now has a way to handle just taking in C code and doing a translation. So I don't know the answer. Steve Scheifhofer gave a talk in 2023 at the latest DConf on how he did his translation from raylib. So that might be useful.
Yeah, it's not necessarily that it handles preprocessing C macros. It's that it can hand the C header files off to the C preprocessor, whatever's on the system. I believe that's the way it works. So it outsources. So great, and yeah, that carried us right through to the end here. So great. I will pick a winner here in just a minute. But Mike, do you have anything else you want to say? Any closing thoughts before we call it?
Yeah. Sure. I guess a few closing thoughts. I should have thought about them more because you've asked everybody the same question.
I do it every DConf Online. It's standard procedure.
But one, I was actually thinking more about the garbage collection, and because that's always the thing that comes up with games and graphics. And if you look in Unreal Engine code, they have their own garbage collector and these types of things. So I haven't found a reason for why that's a barrier, which is kind of interesting. The second thing I would just encourage folks is, try out D for graphics. I'm hoping again to contribute more resources. I don't see why. I think especially as D keeps maturing, it becomes a more and more viable alternative, and it's a competitive advantage, right? If you can find a language that you're more productive in and write better, safer code, D set up for more things like concurrency and so on. So I'm really excited about it. There's a reason I'm willing to, convert all my materials and these types of things to D. It's an expensive cost, but it's a worthwhile cost because I think it produces better engineers, better code, and better outcomes.
All right, thanks. And gosh, I wish I had time to do some graphics programming still. I would love to do it again. All right, so it's time to pick a winner for some D swag. We have 5 names this time. Yay.
All right.
And the winner is 25th. All right. So you're going to win your pick of D swag. If I was going to play sound effects every time I picked a winner, but when we did testing, it was really loud. And if we turned it down too low, it wasn't so interesting. So anyway, 25th, if you contact me, social@dlang.org, or just ping me on Discord if you're there, and I will let you know what you need to do to claim your swag. Also, stick around to the end. After Walter's talk, we'll pick another swag winner, but because you've already asked questions, those of you who have, you'll be eligible to win a $100 Amazon e-gift card. Mike, it's been great chatting with you again. Great to see you. Look forward to seeing you again in London this year.
All right. Thanks for everything, Mike. Thanks, everybody, for watching.
Thank you. And we've got Walter coming up next. See you after the break. All right. Okay, yeah. I'll figure this out. You can go ahead and you don't have to stick around, Mike. Yep.
Ready.
Walter, it is. I see you enough these days. I can't say it's been a long time. It hasn't, unlike the other guys. How you doing today?
Oh, actually, I'm doing great. I was out dirt bike riding and didn't come off too sore with that, so I'm good.
Wow, Attila was snowboarding. You're out riding dirt bikes. I should take up some kind of physical hobby, join the club.
Yeah, when I got
You,
back,
huh?
when I got back to the car, I noticed a gash in my pants over the knee, and I hadn't noticed, and it was writing because when I fell off the bike, I was wearing the knee armor
Uh,
under the pants. So it saved me. The armor saved me from a major injury. So
well, we would hate to have you injured. That would be bad for D.
yeah.
Well, but I guess you don't program with your knees, so that's okay. Go ahead and hurt your knees. Yeah. So you changed your talk. You were going to talk about some types, and you ended up talking about something else.
Yeah.
Uh,
The
Go ahead.
Oh, I keep hearing the delay of the
Oh, sorry.
thing, and I keep thinking you're still talking because I'm waiting for you to stop. I was going to do some types, and then
You've got to mute the YouTube
the news,
thing.
how
Yeah.
controversial it was, and people going, "Why aren't you doing this instead?"
Hmm.
So, oh, wait a minute. Oh, I just muted the YouTube.
There you go. That'll do it.
I didn't know
Yeah.
that was a tongue twister. So everyone wound up talking about on the news group about this other feature that was lacking with D templates and structs. So I thought, well, why not just address that instead? It's a precursor to doing better user-defined type. So why not? So that's what this talk is about. It's a fairly simple feature, so the talk is a little short, and I'm sure that's why you put it last.
Well, no. To be fair, I put you last before I knew how long your talk was going to be. So because
Okay, yeah.
I got
You
Attila at the top. Yeah. So yeah, so we'll have a lot of space to fill after the. But actually, yeah, that works out pretty well. We can end it earlier, and I can go to bed. No. Okay, so we'll get to the talk in a few minutes. But watching the conference so far today, what has jumped out at you?
Oh gosh, what jumped out at me was the high quality of the talks.
Hmm.
I thought they were, all of them were excellent. I'm really looking forward to, Timon's article about his because it's too much information to digest in, quick slides going by like clickety click.
Mm-hmm.
And I just can't understand things that fast. And I really liked his going through the history of tuples in D.
Mm.
There's history in there that I've forgotten, and I think all of that history provides a useful ideas and things we need to think about in any modern tuple design. Mike's great talk about the little niceties in D that make programming in D great, and I really appreciate that. And Robert with how simple D should be.
Hmm.
Robert is probably the most insightful advocate for making D a simple language.
Hmm.
And so I appreciate his insights. And of course, Attila, I missed most of Attila's talk because I didn't get up early enough. I apologize for that. But I saw it was a great talk. Sorry about that, Attila. I'm going to have to watch it on the
YouTube.
watch it on the replay.
Hmm. Yeah. So, do you tuples have been talked about for a long time? It's one of the features that's been talked about for a long time. Some types have been talked about for a long time. Pattern matching has been talked about for a long time, and you are interested in getting all those into the language, yes?
Yes.
And
But last year, everyone talked about you need to do backing and filling. Stop implementing new things, do backing and filling. So, the last year, backing and filling has been a priority.
yes, and but when we do get into additions and we start looking at the next features, I asked Átila this question earlier. We've never discussed actually what the first edition is going to look like, right? I mean, we've thrown some ideas out there, but we haven't talked we haven't planned what feature set or what the first edition is going to look like. And I have my idea about it, about what it should look like. But what is your idea? I mean, once we get additions in, what does the first edition bring to D in your mind?
Safe by default.
Safe by default. Okay. Yep. That's the only thing you've thought about right now for first edition?
That's the major one. A couple of the old preview switches, like the one about promoting byte types before casting them, that's been around forever. I never figured out a way to ease that in. Mm-hmm. It's just going to have to be part of the edition.
Mm. Yeah,
Go ahead.
Oh, I was going to say, yeah, my concept of the first edition is just any features that need fixing that will break things. Anything that like safe by default, turning that on is going to break things. So I don't think we should add any new features in the first edition. It should just be breaking fixes, right? That's the way I see it. But I don't know what other people think. And then we can look at and then we can look at future editions for tuples and sum types and all that stuff. But what is your another thing I asked Átila about, the plan right now with the additions proposal is he's going to do another iteration with the feedback that he got before, the internal feedback, and he's going to get some more internal feedback, and then he's going to push it out for the public to review and give feedback on. Is there anything you want to say about what it looks like right now?
Yeah, Adam Wilson strongly advocated reversing the whole concept from what I was thinking of. I was thinking of old code should compile by default correctly, and you should have to say you want a new edition in order to get the new edition. And he wanted to turn the whole thing around where you have to say you want to use an old edition if you don't want to improve or move forward existing code. So he presented a pretty compelling case about that. I'm not totally convinced of that, but it's what the other languages do. Mm-hmm. And it would not be a good idea to do something completely different from them, I don't think, unless we have a really, really good reason.
Yeah.
So I'm leaning towards Adam's approval on that. The other thing is, why are these not showing up in the new dips.development? Is that where they should be? Oh, yeah. I should say before I forget, before this started, I put the dip proposal for this change I'm going to talk about in the dip development news group.
Oh, you put it straight in the dip development, not the ideas.
Yep.
Okay.
Nope, right in development, along with prototype implementation. And so it should all be good to go by the time we're finished here.
Great. So speaking of that, guys, the DIP Ideas Forum, the DIP Development Forum, they are open. This is the new DIP process. The guidelines are linked. If you're going through the web interface, the guidelines are linked at the top of each forum. So please give feedback on people's ideas and their draft DIPs so that they can know whether or not they want to move forward into the process. Everything is as much under the author's control as we can do it, but it's going to rely on feedback from the community. So please go ahead and look at those forums and give some feedback on those DIPs. Yeah, so you were saying what Adam Wilson thought about the code compiling by default. That has been that's a pretty strong consensus, I think. There was a lot of talk about that when we first talked about additions in the forums. Everybody was saying it should be, old code should be compilable behind a switch instead of by default. So, but yeah, my concept too was that the default edition of D should always compile with the latest compiler. But I've kind of come around to the other way of thinking now with that. So. I was just editing. Yeah, I was really, really slow with the DConf 23 talks, getting them edited and uploaded, but finally got them all done. And I was just editing the Ask Us Anything. I just got that published yesterday. And the last question that was asked was, where would you like to see the language evolve to in the next 5 years? And do we have a better idea of that now, do you think?
We need to certainly do better marketing. Like just yesterday, this thing came on about comparing Zig, Rust, and C++. And, he goes on in there to say that, Zig is not a production-ready language and blah, 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 blah. Why isn't he talking about D, which is production ready? And that's marketing is something we got to work for, and that's one of the reasons why I think that all our presentations today should also be turned into articles and published. So there should be an article version of these. All those little bits here and there help. Also, people should show up on YouTube when languages are talked about. Mm-hmm. And if there's an opportunity to, if it's relevant to say something about D, say something about D. I mean, other languages do that. It's not an issue to do that. I mean, I don't mean to be a jerk about it or run other languages down, but, just if you can, mention D. Like when I talk about improving coding style, I give the examples in D. I don't give examples in C++ or Rust or Zig or C or any of those others. I do the examples for concepts I want to talk about. They're always in D. And those little things make a big difference, I think. I think you've done a great job with the YouTube channel for D. But more articles will help, because I know I often don't click on videos because I don't want to spend the time. I prefer to read an article, and I can read an article in a few minutes to determine if it's worth studying or not. But with the YouTube video, I gotta wait.
Walter, I have evolved on this. I did not get the point of YouTube video tutorials, just the concept of video tutorials. I mean, give me a good article any day. Now, I much rather see a YouTube video. I have completely evolved on this. I mean, it's like a friend of mine moved to ebooks long before I did. He just gave up on paper books completely, and I'm like, I'm never giving up my books. I'm never giving up. I have not bought a new paper book in years now. I am 100% ebook now. I keep coming around on this stuff. Well, here's the concept then. By the way, Walter's talk is shorter than everybody else's, so we can do the pre-talk chat a little bit longer. So here's a concept. Robert, I was talking about him about this earlier. He's always bringing us ideas that are, outside the box, and he was the one pushing for compiler daemons and getting the LSP server built into the compiler and compiling in the background. And you were uncertain about that at first, but you eventually came around. What changed your mind?
It was just inevitable. It just, I'm definitely an old school programmer, but some things you just can't deny their effectiveness and their utility. And, it's just time for me to change.
Yeah, change and watch YouTube tutorials, video tutorials. Well, how much part of getting all of this implemented is going to require, refactoring, and that's been a major focus of yours lately is refactoring. How's that going?
Rather slowly. I'm doing some, and Razvan is doing some. And I'm not sure what the end should look like. I'm just sure that you should be able to parse the code without pulling in all the semantic routines, and the data structures should contain a minimal amount of code so that a library can just deal with the data structures and that doesn't have to drag anything, the rest of the stuff in. So separating the semantic code out from the other code is mainly what I've been trying to do. The bookkeeping and the maintenance of the data structures is one thing. The semantic passes are something else again. So I think distinguishing them will make DMD a lot more tractable as a library. I also discussed with a couple other people who are working on this about, well, the language processor needs to know for a variable declaration where all of its uses are. And because that's a really makes it easy to refactor code. And you don't have to worry about another variable being the same name and accidentally getting refactored along with it. And the compiler doesn't keep track of that information. So I suggested a way that the compiler could selectively enable turning that on in a really easy way. And I haven't really heard back on that, but that's the way I think we should go with that. And that one thing seems to go a long ways towards getting what people want with an interactive code editor. It's just, show me everywhere this is used. The other thing people seem to want is the auto completion, which looks up the possible names that match what you've already typed in and then what those names can do. I'm not sure how to do that yet, but I just thought start with where are all the uses of this name. And so I can refactor them easily because, refactoring is something I do. I don't really need the autocompletion, but the refactoring would be really nice because I'm using grep to try to find all the instances, and D frequently uses the same name in multiple contexts, which causes trouble with that.
Well, we've already got the LSP server that Jan uses, WebFreak, in his plugin, but having it built into the compiler is just going to be a game changer, I think, and it's going to make it available to a lot more tooling. Yeah, I'm really, I think more than language features, that's what excites me the most is, where I'm not even interested in compiler programming, but the architecture changing like that and running it as a daemon, that just I just love that concept. So I'm really looking forward to that. But yeah, so let's tie that off, I guess. And anything you want to tell people as a kind of to tee up the talk here?
Oh, I just want to mention one other thing that I've been doing in refactoring, and that is I've been removing all the code that exits the compiler, because you don't really want that in your library version of the compiler having an exit. So, I've been removing all that. To tee out this, I hope you like it.
All right, that'll do it. So I'll go ahead and switch over now. We'll see you guys on the other side.
Hello, everybody. Today I'm going to be talking about a proposed new feature of D, and at the end we will drink the tears of our competitors. I was going to do a presentation on pattern matching, so I started doing a little catch up on what was going on with pattern matching here before. And then I realized that pattern matching depends on subtypes. So I made a dip about subtypes a while ago. There's a link to it. And subtypes turned out to be controversial. There's a link to the thread with all the controversy. One thing stood out in the discussions: a long requested feature was improving the ability to create template types that were as good as built-in types. And this has come up over and over again. And I thought, instead of working on subtypes, I should work on another basic feature underneath that and get that to work right. So that's what this presentation is going to be about. Implicit conversions. Consider how built-in slices work. You have constant, or you have a slice of constants, or a constant slice. It's kind of a tongue twister. And we have two functions, one that takes each type, and then two types. And we see with the basic types that it's sort of cross implicitly convertible. One is implicitly convertible to the other. And the two calls to moon 1 and moon 2 with the two different types. This tests all four combinations, and they all work. The nice thing about this, it's been working this way ever since we implemented const, which is 15 years ago, maybe more, and no problems have showed up with this. It clearly works. So let's try it with a template. And we take a template, and the only member of a template is a slice. And once again, we have our two moons, and they take two different versions of it. One is it's parameterized by a const, and the other one, the whole thing is const. And we try this out, and we see that half of it works and half of it fails. This is kind of embarrassing because with D templates, you're supposed to be able to create new types. And here we have a fundamental limitation on things we can do with built-in types that we cannot do with templated types. So the question is, how do we solve this? The first thought that appeared on the news group is make them the same type, and then implicit conversions will just work and everyone will be happy, right? Well, here's the problem with that. Let's say we take X and we have T, and we instantiate it with a const T. Now T is const and bar takes a const. But if we convert that to a const struct instantiation, we'll find that bar has become a different function. And so the two types cannot be the same because they have different contents. Or, I mean, they can have different contents. Things are even worse. If we use a static if to insert or remove members, we can create structs of different sizes depending on whether the const is applied to the T or to the struct as a whole. And we really cannot allow this to happen because two types that are not the same cannot be the same. So we need to figure out a better way to solve this problem. There's another explanation. It turns out that const int, they're not the same type either. So it isn't strictly necessary for our template version to be the same type. We only need implicit conversion with qualifier conversion. And there's a link to qualifier conversions. Other kinds of implicit conversions will not be considered in this proposal. If someone, I didn't see the point to supporting that, but if someone else sees a point and wants to work out what the inevitable rules for that should be, that would be interesting. But this one's going to be strictly with qualifier conversions. So let's down to our key insight. Implicit conversions work on built-in types. We can always convert the top level without damaging the tail. So we can convert the top level from a const to a non-const and vice versa. And it works, and it works because it can be trivially copied. What we want to do is apply that same principle to structs and classes. So our method is we're going to look at each of the members in the struct and see which ones are necessary to make this implicit conversion work. We have fields and we have non-static member functions. Those we're going to look at, and we're going to ignore other members such as enums and type defs and static member functions as being not relevant to the conversion. With fields, we're going to go through the fields one by one and attempt to match the names, the ordering, the placement, and each of these fields needs to be implicitly convertible to the field in the struct it's being converted to. With non-static member functions, we need to match the names, of course. We might need to match the ordering in there in case they are classes. And the address of a function in one type has to be implicitly convertible to the address of the corresponding function in the other struct. This works exactly like the rules we've already worked out for overriding functions, and it's called covariance of the operands and contravariance with the return type of the function. And then it will be binary compatible. If all these tests pass, it is implicitly convertible. Okay, here's the beauty of this, is we're not really inventing anything new. It's principled, it follows all the existing rules, it does not create any weird new rules, it does not break the type system, and it does not create holes in the type system. Some of the other proposals, like having a special function with a special attribute to do the implicit conversion, isn't necessarily going to follow the rules of implicit conversions, and it could, if it's not correctly implemented, it could open up type holes in the system. So I object to that method of doing that, and instead have the language do the work rather than the user creating a special function to do the work. What's this going to do with existing code? Well, if existing code relies on those conversions not compiling, well, it's not going to work. But I couldn't think of any legitimate code relying on that. And that, of course, doesn't mean that doesn't happen and isn't useful. So can we consider this a bug fix rather than a new feature? I'm kind of on the fence on that. I'm curious what everybody else thinks about that. The neat thing about this, we can do implicit conversions of structs and classes under most circumstances. We can do things like wrap a slice in a struct and then have it behave more like a slice rather than having certain abilities of slices not implementable as a template or a struct. What I like about it is there's nothing clever about it. All it's doing here is, let's take the idea and we pull on the string, and the decisions about how it must work are not invented. They simply become inevitable. And we'll see how this influences things. Several people have asked for a feature like this, and I'm curious to see what kind of things are going to result from it. Okay, I mentioned tiers in the beginning. Well, this is the same idea in C++, and you'll notice it has the exact same failing that D does have today. So I think once again, D is going to take the lead in innovation on this, and we can expect our language competitors to eventually copy the feature. So I'm proud that D is a leader in this sort of thing. Anyhow, I hope you like it, and I hope to get it implemented soon and having a PR and a dip up for it for your criticisms, comments, and approval. Anyhow, thanks for listening. Bye.
All right. Thanks for the talk, Walter. And if you have a question for the Q&A session here, please prefix it with Q : so I do not miss it.
Okay, well, I have a little bit of an update from when I recorded that presentation. There's a dip for it now and a pull request for it now up, and there's a link to it in the new D or the dip development thread. I also forgot to mention that this feature may strongly influence the redesign of ranges, which Jonathan Davis is working on. So I hope that means that we can get a better implementation of ranges because of this feature. Another thing that's happened is when I built the prototype for it, it works with structs that are just have fields in them, but with some more complex structs, when I ran it through the test suite, some problems showed up. So I'm going to have to figure out where the weaknesses are in this that are causing those problems and plan to fix them. I don't see a showstopper in there. It's just something I have to figure out.
All right, Walter, first question for you. Do you think people should add written in D to synopses?
Yes. Why not? I mean, everybody's sick of, tic-tac-toe, written in Rust, but, it works, so why not?
All right. Ali says, please see a couple of lines above. All right, I got to switch over here. Here we go. Can a property function of a struct match a member variable of another struct?
No, because the comparing of them goes field by field and function by function, and it won't know anything about property functions. So you can't replace a field with a function and expect the implicit cast to work. It won't. It has to be structurally conformant. It has to not only behave the same, but be implemented the same.
Okay. And from Monkey, I'm very, very far behind, but I think D should focus on making progress on data structures and algorithms, and I'm just not seeing political changes that would allow the necessary breaking changes.
I'm not understanding the point.
Well, containers are a top priority for us now, and it actually, yeah, I guess you missed this earlier. You sent me a link to something you wrote about containers and asked me to bring it up in a meeting, so I did. And we discussed it a little bit at the time. And then in a future meeting, maybe a planning session or the next monthly meeting, I don't remember exactly, we were looking at, I had asked everybody to rank a list of things that we had come up with in the past for priorities. And containers surprisingly floated to the top. And since containers is going to be a priority for us now, which Robert is leading the effort on, that's also bringing allocators into the picture because the container implementation is going to rely on allocators. And so Paul Backus has volunteered to contribute to that along with Steve Schweighofer. And so those are happening, and Jonathan Davis is working on the new ranges, the new range API, and I guess algorithms are going to be revisited as part of the redesign of the range API and Phobos 3. So is there anything you can say about that, Walter, off the top of your head?
Containers are not my area of expertise, so and you know, there are other people in the D community that know a lot more about them, and they should take the lead on it. I kind of see mine as like this proposal in this talk should make containers easier to make. For example, the example in the slide was you take a slice and you're able to put it inside of a struct, and then you'll still be able to implicitly cast it, which is a very valuable feature for slices. And so I think that this new feature I propose is a gateway feature to having better container libraries and better ranges. So that's where I feel I can help.
So if anybody's interested in contributing or providing input on the container API, please reach out to Robert Schadek. And you can help out with the Phobos redesign or contribute ideas, whatever. Talk to Adam Wilson or Jonathan Davis about the ranges. Next up, not a question, more of a comment on bug fix versus feature. I think this should be added in the first language edition with any other potentially breaking features.
Well, this isn't supposed to break anything. Although it did when I ran it through the test suite, but I can't really have an opinion on that until I figure out why some of the tests didn't work.
So yeah, this is something we talked about earlier. Átila was saying that if a new feature doesn't break anything, there's no reason why it can't go in the default edition of the language. It doesn't need to bundle. You agree with that, yeah? So ideally, this should go into the base version of the language if it's not really breaking anything. Yes.
Yep.
Okay. Cool.
Unless, well, if it breaks code that is already broken, then that's okay.
Okay. Okay. All right. And Pavel S., what chance have quad trees and oct trees data structures have to get into D standard library?
I guess you'll have to talk with Robert about that.
Yeah, we haven't talked about any specific data structures, but if you watch Robert's talk, I believe he did mention that he thinks that the built-in arrays and associative arrays are good for the vast majority of cases that people need. So beyond that, that smaller percentage that those don't cover easily, I guess that would include quad trees and oct trees. I don't know, but yeah, that's something to talk with him about. So sorry we couldn't say more to that.
Well, it's interesting, the observation that hadn't occurred to me before, that the built-in arrays, slices, and associative arrays are so good that they kind of supplant the need for more complicated custom data structures or containers. So that's interesting to hear. I know that what I usually reach for is an array or a hash table, and haven't really felt it for others very much.
And in the past, what I've done when I've just taken an array and wrapped it in a struct and added some, extra functions to it, and boom, I've got, a queue or whatever, right? So it's easy to do. It's simple. Serg, what about other languages? Rust, Zig team have a point that all implicit is a bad thing. Implicit in Scala is one of the hardest parts of the language. Wouldn't this feature complicate code understanding?
I think that's a really good question. I think the trouble comes from, like with slices, if you want to, are the members of the slice constant, or is the slice container constant? And with implicit conversions, you don't have to worry about it. You can, if you say it's const, you can copy the head and then still access the const members of it. And implicit conversions, if you use them properly, can eliminate a lot of overloads. For example, if you had to specifically write a const t and a non-const t, and then you have a combinatorial problem, as if you have multiple parameters to the function. Let's say you have 5 parameters, and each one can be const or not const. Then if you're doing overloading, you have 5 factorial functions you've got to implement. And that's just not workable. The whole point of in-out was to avoid C++'s problem with having the combinatorial effects of not having the implicit const conversions in it. So we wish to avoid that and cut down on the number of overloads. If you're having problems with overloads and implicit conversions, I would suggest that you really should revisit what your overloads actually are. I think overloading is a confusing feature if it is used too much, and we often tend to use overloading too much. And I've even had to resort in some Phobos things, putting pragma messages inside the various overloads to see which one was actually selected. And that shouldn't be necessary. To me, that's a sure sign there are just too many overloads. It's being abused. Sometimes overloads are used because somebody can't think of another name for something. The functions can be totally different in their implementation, but they use the same name, and overloading to distinguish them, that's just wrong. I've actually seen that in the DMD source code now and then. 2 functions with the same name and only a vaguely related purpose, but they're overloaded against each other. It's just wrong.
All right, and next, I guess this is connected to the earlier question about quadtrees and octrees. What chance does the GLTF file format importer have of getting into the standard library? So yeah, I can see you're coming at this from a game development perspective or a graphics development perspective. Yeah, quadtrees and octrees, who knows if they have a chance of getting in or not, but I wouldn't expect GLTF file format importer to get in. That seems like a very specific, that's a very narrow field of use, I think. I know we're talking about expanding more general formats for like YAML and other things like that, a better JSON parser, a better XML parser. But I don't see graphics format importers or exporters being added to the standard library. What do you think, Walter? I mean, that's just my speculation. I'm not the one to say.
Why? I can't help it. I don't even know what GLTF is.
It's a 3D file format. It's a 3D file format. Let's just leave it at that. Something transition format or whatever. But yeah, I mean would you expect to see 3D file format importers and exporters in the standard library? Yeah.
No.
Yeah, I would.
Graphics is its own world with its own ecosystem, and I kind of think that a graphics library should be something that you should specify. I want to import this graphics library, not be part of Phobos.
Yeah.
Phobos should be just the bread and butter stuff that most everybody's going to need.
All right, and Timon says, you can read that, can't you, Walter? What about struct s blah, 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 blah? Will this convert between different parameters A?
Yeah, I leave it to Timon to knock a hole in.
That's why he's around, right?
Yeah, that's a great question. I don't know. Oh boy. Yeah, I'll have to see about that. Maybe alias parameters would have to be disallowed for the implicit conversion to work. I mean, that would be the nuclear option on this. But I think I'm going to have to wind up finding all the cases where the implicit conversion doesn't work and, blocking them. So that only the core thing is going to work, and that may be inevitable, and this may be one of the things that aren't going to implicitly convert because of this issue. Yeah. Oh, there is that thing where the functions with the same name have to be covariant, and that would probably catch this case. Because you're passing in a different function, and if it's not covariant, it isn't going to work. So maybe I'm in the clear on this.
Yeah, all right. And Rising Dad asks, how do you decide what could and could not be included in the standard library? What is the disadvantage of including more?
A long time ago, Andre and I decided that we wanted the standard library, instead of to be a giant grab bag of functions, it should be a smaller bag of very carefully selected deep functions that the user is not likely to be able to easily implement himself. So instead of a mile wide and an inch deep, we kind of wanted it to be a more narrow and deep functions, not collections of trivia. Phobos 1, for the old version D1 of the language, we accepted anything and everything because we needed Phobos to grow. And, that didn't turn out too hot. So the best answer I can give on that is it depends. I mean, does JSON really belong in the standard library, a JSON parser? Well, it turns out that implementing one in the library badly spawned a large number of JSON implementations, some better, some worse, that are in Dub. Is that really a better approach? I'm not so sure. JSON probably should simply get a better standard version in the library. Some things are very difficult to implement correctly, like floating point math and all that. Those should be in the standard library, all the standard functions, of course. The generic algorithms, I think there's a big advantage to having an expert like Andre implement them and put them in the standard library. And those have been a big success. IO, of course, that's just everybody expects that to be in the standard library. The date and time stuff. The crypto stuff that's in there, the hash generators and things like that. The problem with those is if you implement them wrong, it can cause big problems. So we try to put one in the standard library so you have one that actually works correctly. So all I can say is I have to look at them on a case-by-case basis.
All right, well, here's a related question. How about implementing an event loop? There's always an issue when everyone implements their own.
Well, since I've never done an event loop, or at least not since doing interrupts in the olden days, I don't have a good handle on what's the right way to do that. I would not recognize the correct one if it hit me in the face.
Well, I know there are.
Implement one that is the ruler of all event loops. Sure, give it a try.
Well, we've got a few on code.dlang.org. But there's there are some things that people expect to be in the standard library, coming from other languages that have this kind of thing now, like a simple HTTP server, to get up and running, or things like that. So the question is, does D go in that direction, or do we stay more minimalistic with building blocks? And I think that's a really big question that needs to be answered in the design of Phobos 3.
It is a great and open question. Yeah. How far should we go? There's really no limit to how far we can go or leave out.
I mean, on the one hand, you've got people who think the standard library should just be a dub package and leave it at that. Yeah. And Adam says here, event loops are actually hard to get right, but a standard mediocre one is better than a fractured great one.
Yeah, might be right.
Because a standard offers interoperability.
Well, that's how the unit tests worked out. Having a maybe not best of breed, but one that was there and it actually worked turned out to be an enormous advantage and a boost to using D. And the same with the documentation generator. When we first did the documentation generator, everyone says, oh, what about deoxygen? What about all these third-party ones? And DDoc was good enough, it just destroyed them, at least for use with D. So that shows the advantage of having the built-in ones be just good enough that people don't need the other ones.
Well, Walter, we were joking about how your short talk would make for a early end, but you've gone longer here than anyone else. So I'm going to ask Walter now to go ahead and give some closing thoughts. If you've got any more questions, I'll go ahead and take one or two more if any more come in. And then we'll start picking names for the final D swag item and the $100 gift certificate for Amazon. So Walter, closing thoughts.
My closing thought is, Mike, you've done a fantastic job once again. I think
Thank you.
The only things that could compete with it are your previous work, and you've outdone them all on this. So you set a new bar on.
Well, that wasn't me. That was the software. Yeah.
So thank you. Without you, none of this would have happened.
Thank you, Walter.
I appreciate that.
That means a lot to me. And I wish we could have gone 2 days this time. like we've done in the past. So, we did not do DConf Online last year because in 2022, we did it too close to the real world DConf. It was only like 4 months away, and it was just too much. So I wanted to get some space. So hopefully if we can settle on real world DConf in September, then we can keep doing DConf Online every March, and we'll have a regular clockwork pattern. That's the hope. And so next year I would love to see more talks so we can do this 2 days. So
one more thought. All you people who thought about doing a presentation for this DConf but didn't, aren't you sorry now?
And I want to highlight this because this is Adam Roop. This format is much better, and this was Adam's suggestion. He is the one who suggested it the last time we did DConf Online. So yeah. So let's go ahead and pick the winner for this session. For a a D swag item. If I can remember how, oh, right, just click. Here we go. Who's it going to be? All right, Pavel, just please email me social@dlang.org or ping me on Discord if you are there. And so now it's time to pick a winner for the $100 gift certificate from Amazon. Let me just get this sorted real quick. Eliminate duplicate names. All right, and here we go. $100 gift certificate goes to Mike Shah. Too bad Ricky's not online. I remember last time we did DConf Online, this was there was an ongoing joke about Ricky never winning anything. The random number generator was biased against New Zealand or something. So yeah. All right. Thank you everyone for attending and watching and asking questions. And I look forward to seeing you at the Real World DConf in September in London. I'll be launching the website later this week and hopefully opening early bird registration at the same time. Just got a few details to work out before I can do that. But even if the early bird registration doesn't open this week, the website is still going live. We are accepting submissions right now. I put out an announcement earlier in the forums. So please, if you're thinking of submitting to DConf in London, September 17th to the 20th, please go ahead and get your submissions in sooner rather than later. That'll be better for us to get everything in early. And that's it. Thanks again, everyone. Thank you. And have a nice weekend. I'm going to go hop over to BeerConf now. If you're around, I'll see you there. Bye-bye.